specific data in the data frame. So here, for example, I write the name of this data frame and then I write .log. And then let's say we want to get the data inside the index 0. So we press Ctrl Enter and we get all the data that corresponds to the index 0. But now let's say that we only want the data that belongs to the index 0 and also to the column ID. So now I only have to write the ID column and then run, and we get this ID. And now we're going to change the value of these IDs for only the first 1000 rows. So now we set this equal to the ID that I created, this one, that is TT12345 until 9 and then 0. So this is the value. And now that this is ready, I'm going to run this code. So now I run. And now let's see the data frame. So now I'm going to print df_movies_2. And now you can see that the first 1000 rows of this ID column have this TT123456789 and 0. So we successfully changed the data inside the first 1000 rows. And now I'm gonna make this merge. So first I write the name of the data frame df_movies_2, then .merge, and then parentheses. Then I write the name of the second data frame, and then the on parameter equal to this ID column, and then the how parameter equal to the outer value. So here with this we get an full join. But now if we add the indicator equal to true, and if we add also the query, we can get this exclusive left join. So here I write .query. And now inside parentheses, I'm going to write the same code I wrote here. So merge equal to left only. So every time we want to make a left join, we can use this query. So in this case, this query helps us get the exclusive left join. So we paste it here, and now this is ready. So we can run this cell and see the results. So I run, and now we have this data frame, and on the underscore merge column, we see that the data that we have is only left underscore only. So apparently everything is correct. So now I'm going to set a name for this data frame, and the name I'm going to give this data frame is df_exclusive_left. So now I run this, and now we have this data frame. And now let's find the shape of this data frame. So first the df_exclusive_left. So I use the shape attribute. Now print, now parentheses, and now I copy and paste this twice. So now we have this, and now I write the name of the df_movies_2 and also df_ratings. So now I run this cell, and now let's see the result. And here we see that the first and the second data frame have around 85,000 rows. However, the df_exclusive_left data frame only has 1000 rows. And this happens because this 1000 rows is exclusive to the df_movies_2. And these 1000 rows correspond to this ID I created. So this TT123456789 So I created this ID in purpose because this ID didn't exist. So those IDs were unique to this data frame. And this is why in the exclusive left join, we only got these 1000 rows. So this means that the other 84,000 rows aren't exclusive to df_movies_2. So probably they also belong to this df_ratings data frame. And that's it. In this video, we learn how to make a left joint and also an exclusive left joint in pandas. Okay, in this video, we're going to learn how right join works. A right join allows us to grab the data of the second data frame or the second table. So consider this diagram. Let's say that the data frame on the left is the first data frame, df1, and the data frame or table on the right is the second data frame, df2. So a right join will grab only the data that corresponds to df2 or table 2. So this data is the data that is exclusive to df2 and also the data that belongs to df2 and to df1, so the data in common. This right join is represented by the white dots in this diagram. So now let's see an example. These are the data frames that we've seen in the previous videos. So we have df1 and df2 and the ID column, that is the column that these two data frames have in common. And now let's see how this data that is inside the ID column will fit into the diagram that we had before. So here we have the data that is inside the ID column, so A, B, C, D, E, and F. And now we see that the right join only covers the IDs C, D, E, and F. And this happens because this data corresponds to the df2. So C, D, E, and F belongs to df2, while A and B doesn't belong to df2. So only the data that is exclusive to df2 and also the data that df1 and df2 have in common will be taken by the right join, as you can see in this diagram. Okay, now let's see how to make the right join using pandas. So first we have to identify the column in common. So in this case is the ID column. And after we do that, we have to use again the merge method. So we write df1.merge and inside we write the second data frame, also the column in common in the on parameter. And then we write the type of join in the how parameter. In this case, this is a right join, so we write how equal to right. And after we write this, we're going to get the following output. So this is the data frame that we get as output. So here we see that only the data that corresponds to C, D, E, and the F ID is in this data frame. And this happens because these IDs belong to df2. And now let's see how to implement this right join in pandas. So let's go to Jupyter Notebook, and here I'm going to use the df1 and df2 data frames. So let's write the code to make this right join. So first df1.merge, then parentheses df2, so this is the second data frame, and then the on parameter equal to ID and the how parameter equal to right. So with this we make this right join. So now let's run this code and we get this data frame. So it's the same output we've seen before. And as you can see, making a right join in pandas is as simple as that. Okay, now let's solve an exercise to challenge ourselves a bit more. And we're going to follow these steps. First, we're going to extract a 30% sample of the df_ratings data frame. Then we give a name to this sample. So I'm going to name it df_ratings_sample. And then we make a merge, so between the df_movies and this df_ratings_sample that we created in the first step. And in this case, the type of join that we're gonna make here is the right join. And after you do that, you have to calculate the shape of the data frames so we can know what's going on behind the right join. Okay, now is your time to solve this exercise on your own, and after you finish, you can continue watching this video to see my solution. Okay, to solve this exercise, first I'm going to extract a 30% sample of the df_ratings data frame. So I write df_ratings, then that sample, and here I use the frag parameter. So here equal to 0.3, and now I give a name to this data frame. So I'm going to name it df_ratings_sample, and now I run this and I just created this data frame. So now I'm gonna merge the df underscore movies and this new data frame. So I write df underscore movies dot merge, then the name of my second data frame, which is this new data frame I just created, and then the on parameter. And after this, the how parameter. So on the on parameter, we have to write the column these two data frames have in common. And this column is the ID. I'm gonna show you here. So I'm gonna use the columns attribute and it's here. So ID. And now I paste it here. And in the how parameter, I set it equal to write because we want to make a write join. So this is ready. And now I'm gonna run this code. So I press Control Enter, and now we made this write join. So we have the data that belongs to df underscore ratings underscore sample, and also we got the columns that belong to df underscore movies. So now I'm gonna name this data frame, and I write equal to, and here df underscore write. So this is the name of my data frame that we got after making the write join. And now I'm gonna run this, and here I calculate the shape. So first df underscore write dot shape, and now I paste twice. Then I copy the values of the data frame. So df underscore movies, and the other is df underscore ratings underscore sample, and the last one is the df underscore write, so it's here. And now I print these three shapes, so I use the print function, and here I copy and paste, and now we have the shapes. So we see that the number of rows between the df underscore write and the df underscore ratings underscore sample are the same, and this happens because we made a write join, and with this we obtain only the IDs that belong to the second data frame, in this case the df underscore ratings underscore sample. So all the data that corresponds to those IDs will be available in the df underscore write. However, the IDs that only belong to the first data frame, so df underscore movies, will be excluded. And this is why some of the 85,000 rows from df underscore movies were not considered in this write join. And that's everything you need to know about the write join. Now let's see the next type of join. Okay, now it's time to see exclusive write join. And this type of join is similar to the write join, but here we're gonna exclude the data that the data frame 1 and data frame 2 have in common. So the only data that the exclusive write join will grab is the data that is exclusive to the write table, or the second table, also known as the second data frame. So this is the area that is covered by the white dots. So that area represents the exclusive write join. And now let's see an example with the same data frames we've seen so far. So df1 and df2. And now let's see how the IDs fit into this diagram. So here we see that only the E and F IDs will be taken by this write join, because this is the data that is exclusive to the df2, or the second data frame. So now let's see these two data frames again, and we can verify that the IDs E and F belong only to the df2, while the other IDs either belong only to df1 or belong to both df1 and df2. So now let's see how to make this exclusive write join in pandas. So first, as always, we have to find the column in common, in this case the ID column, and after this we use the merge method. So we write df1.merge, and inside parentheses we write the second data frame, the column in common in the on parameter, and in the how parameter we have to choose the outer join. So in this case we have to write outer because as I told you before in some other video, as a rule of thumb, every time we want to make an exclusive join, we have to write the word outer in the how parameter. And after this, we have to add the indicator parameter and set it equal to true. This indicator will create a new column named _merge, and in this column, we'll see which data is exclusive to the df2 or to the second data frame. So after we do this, we have to use the query method to pick only the data that is exclusive to df2. Alright, now let's see the output of this exclusive write join. And the output is the data that corresponds to the IDs E and F. And we see that the H column is empty because the second data frame, also known as df2, doesn't have this column. For that reason, we got null values in this H column. Alright, now let's see how to implement this exclusive write join in pandas. So let's go to Jupyter Notebook, and here let's write the code. So I'm going to use df1 and df2 as I did in previous videos. And now I write df1.merge, then the second data frame df2, and then the on parameter, here ID, then the how parameter equal to outer. So with this, we make a full join or outer join, but now we want to make exclusive write join. So we have to add the indicator parameter and set it equal to true. So this indicator will create the merge column, and this merge column will tell us which data is exclusive to the second data frame. And this type of data is represented by the write underscore only. So this means the data that only belongs to the write data frame. And in this case, the write data frame or the second data frame is the df2. Okay, now let's create a query that only picks this write underscore only data inside the underscore merge column. So now I copy and paste this code here. And after I do this, I'm gonna create a query. So here dot query, then parentheses, and now I open these quotes, then I write the name of the column. Actually, I copy the name of the columns to make it faster. So now this column equal to, and now the name of the data I want to pick, in this case is the write underscore only. And that's everything we have to do. Now we can run this cell, and we're gonna get only the data that is exclusive to the second data frame. So here you see that this data is exclusive to df2, and with this we successfully created our exclusive write join. Alright, now let's put everything we learned into practice, solving an exercise. So in this exercise, you have to make a copy of the df underscore ratings data frame. And after you do that, you have to set the first 1000 values of the ID column as the ID that I created here. This is an ID that I just came up with. And you have to set that value to the first 1000 rows in the ID column. After you do that, you have to merge the df underscore movies and the df underscore ratings underscore 2. This data comes from the first step, which is this one. And the type of join you have to make is the exclusive write join. And finally, you have to calculate the shape of all the data frames involved in this exercise so we can draw some conclusions. And that's everything you need to do in this exercise. So now try to solve this on your own, and after you finish, you can continue watching this video to see my solution. Okay, to solve this exercise, I'm going to start by making a copy of the df underscore ratings data frame, and I'm going to use the copy method. So I write df underscore ratings dot copy parentheses, and with this we're going to create an independent copy. So now I'm going to set a name for this data frame, and I'm going to name it df underscore ratings underscore 2. Now we run, and we created a copy of the df underscore ratings data frame. Then to set the first 1000 values of the ID column as this ID that I created, I'm going to use a for loop. So here I write for index in df underscore ratings underscore 2 dot index. So we're going to loop through the df underscore ratings underscore 2 data frame. So now I write colon, and here I'm going to write a condition. This condition will limit the changes we're about to make to only the first 1000 values. So we write if index is less than 1000, then execute this line of code. And in this line of code, we're going to change the value of the ID column. And here I'm going to use the log method. So I write df underscore ratings underscore 2 dot log. And here I use the index and the column. The index comes from the index that I created here for this for loop. And the name of the column is going to be this column ID. So I write the imdb underscore title underscore ID and then set it equal to this ID. So now I copy this ID and I paste it. So just a recap in case you didn't understand what I did so far. First, we looped through the indexes of df underscore ratings underscore 2. I'm going to show you the indexes here so you understand much better. So the indexes start with 0 and ends with 18,855. So we're going to loop through all these values, but we're going to limit the changes that we make with the log method to the first 1000 indexes. So with this, only the first 1000 indexes will have this new ID value. Okay, now let's run this code, and now we change the values, and now let's see this data frame. So I print now df underscore ratings underscore 2, and now you see that the first 1000 rows in the ID column have this TT123456789 value. So now I'm going to merge the two data frames. So df underscore movies and df underscore ratings underscore 2. So now I write df underscore movies dot merge, then the second data frame, and then the own parameter, which is equal to the column in common. In this case is the ID column, as you might remember from previous videos. Then the how parameter equal to outer, because we want to make this exclusive join. So we have to set it to outer. And then we add the indicator equal to true. So now I'm going to make the query. And to select only the data that is exclusive to the second data frame, I'm going to use this code that we previously created here. So this merge, which is equal to write only, allows me to pick only the data that is exclusive to the second data frame or to the data frame on the right. So now I copy this, and after we do this, we paste it inside the query. So now everything is ready. We can run this code. So now we merge these two data frames, and we see that we have some null values, but that's fine because the second data frame doesn't have these title, years, genre, and country columns. So it's fine. Now let's verify that we successfully made this exclusive right join by analyzing the shapes of the data frames. So now I'm gonna set a name to this exclusive right join, and I'm gonna name it df underscore exclusive underscore join. So now I run again, and now we created this data frame. So now let's examine the shape. So now I write this dot shape. Now I paste twice, and now I write the names of the other data frames. So df underscore ratings underscore 2, and also df underscore movies. So now it's ready. I'm gonna put this first, and now let's print this so we can see the shapes of the three data frames. So I print, and now I run this code, and we see the shape of these three data frames. All right, now we see that the data frame we got after making the exclusive right join only has 1000 rows. And this happens because only this 1000 rows is exclusive to the df underscore ratings underscore 2, which is our second data frame, or let's say the data frame on the right. So this data is exclusive to this second data frame, and for that reason we only got 1000 rows in this data frame. And that's it. In this video, we learn how to make the right join and the exclusive right join in pandas. Alright, in this video, we're gonna learn some meta characters used in regular expressions. So, in regular expressions, meta characters are understood as characters with a special meaning, like the /d, /w, and /s. And in this video, we're gonna see the meaning of these characters and also see some examples. To easily explain you how regular expressions work in Python, I have on the left a website called regex 101, and this website allows me to test some regular expressions, and I have here a text that we're going to use as example, and on the right I have a list of meta characters with their meaning. So first I'm going to explain you the meaning of each meta character, and after that you can remember the meaning by looking at the right side. After we learn all these special characters in Python, we're going to go back to Jupyter Notebook and test some regular expressions using the Jupyter Notebook text editor. Okay, now let's start with the first meta character, and this one is the /d or \d. And this meta character helps us get the digits from a text, so the numbers from 0 to 9. So let's test it out. So the only thing I have to do here is to write the / followed by the d. And as you can see here on the left, we have the numbers highlighted in blue, which indicates that this regular expression \d gets all the digits from 0 to 9. Okay, now this \d, as most meta characters, have their negation, and their negation get the opposite values of each meta character. Okay, now let's get the negation of \d. In this case, the negation of \d is \, but now d in uppercase, so this one. So if we write \d in uppercase, we're gonna get not digits. So we're gonna get from the text all the elements or all the characters that are not digits. So let's try it out. So here I write / and now d in uppercase, and now you see that all the characters that are not digits were matched. And this includes even white spaces and also this hyphen. So anything that is not a digit will be matched if we use this \d in uppercase. Okay, now let's see the next meta character, and now is the \w. And this one means word character. So this includes letter from A to Z, and then from A to Z, but now in uppercase. And also the digits from 0 to 9, and also the underscore. So keep this in mind. I used to forget about this underscore, but this underscore is included as a word character. So now let's try it out. So here I'm gonna test it out. Here I write / and now w. So as you can see, all the word characters were matched, and those that weren't matched aren't word characters. For example, here the period is not a word character. Also, these exclamation marks are not word characters. Also, the hyphens are not word characters, and the rest is a word character because we have here digits, and also we have here letters either in uppercase or in lowercase. And to get the negation of this \w, we have to use the \w, but now in uppercase. And now we get not a word character. So this \w in uppercase is not a word character, as you can see here on the right. So now let's write this \w in uppercase, and here we see that these spaces here, this is a space. This isn't a word character, so it was matched. Also the period and the exclamation marks as we've seen before. And well, keep that in mind that this blank space counts as a character, and in this case is not a word character, because sometimes people used to forget that the blank space is there, but yeah, it's there and it's not a word character. And now it's time for the \s, and this \s means white space, and this includes a space, also a tab, and new line. So if you don't know what I'm talking about, well, the space is only this. This is how I make a space. Then the tab is this, and the new line is only when we press enter and we get a new line. Well, it's as simple as that. So now let's try this out. So here I write \, and then the letter S. So here I have \s, and now we matched all the white spaces. So this white space between the words hello and world, also this new line that is after this period, and then we have a lot of blank spaces, and then again here the new line, and so on. Just keep in mind that this last line, this one, doesn't have a new line, because here we don't have like a next line. We don't have a new line. But if I press enter, here we automatically get this blue selection. So this is in blue because now we pressed enter and we created a new line. And if I press the delete key, we'll see that that new line disappeared and is not matched anymore. Okay, the negation of this \s is the \s in uppercase. In this case, it's not white space. So this means like the opposite of white space, as simple as that. So now I write \ in uppercase, and as you might expect, we get everything that is not a space or a new line or a tab. So this is what we got. Okay, now let's see another meta character, and now it's time for the that. So this period or that sign matches any character except for a new line. So when we write this that sign, we're going to match any character that is not a new line. So now let's test it out. So here I write the dot sign, and here we matched all the characters except for the new line. So here you see that we match this space, and also the dot sign, and also these exclamation marks, but not the new line. So here, this new line that is supposed to be here after the period is not matched. And also all the new lines that are at the end of each sentence, they are not matched. Okay, now there isn't such a thing like the negation of this dot sign, but if you want to ignore these special characters, and not only this, but any special meta character, you can use only this \ to ignore any special character. So let's try it out with this dot sign. So now this dot sign is a meta character, so it's a special character in regular expression. But now if we add the \ here, we're gonna see that we don't get anymore any character except for new line. So as you might remember, this dot sign gets any character except for new line. But now I added the \ and this isn't true anymore because this \ ignores any special character. So this means that we escaped that dot meta character, and now this is only a regular character. So the only thing that matches is this regular dot sign, so it's the only thing that matched, and the rest didn't match because this is only an average dot sign. And that's how the \ works in regular expressions. Okay, now let's see some special symbols, and we have two special symbols that help us match elements at the beginning or at the end of a string. So first, let's start with the caret symbol, which is this one that you see on the right, and this symbol matches the beginning of a string. So let's try it out here. Let's see how it works. So let's say that we want to match the word hello, which is this one. So if we want to do that, we only have to write hello, And that's it. Yeah, we can get the hello world. But now what happens if we have this? So we don't have one hello, but we have two hellos. So here we have hello world and again hello. So if we only want to match the first hello, we have to use the caret symbol to match only the beginning of a string. So here, if I write a caret, we'll see that the only element that matches is the first hello, because here is the beginning of the string. So it starts in this part, matching elements, and now it ends here. And since this hello isn't at the beginning of this sentence, it's not considered for this caret symbol. But what if we want to match the second hello, so this one? Well, in this case, we can use the dollar symbol, which is this one. And this matches the end of a string. So if we write here dollar, but now first delete the caret and write the dollar, we'll see that, well, nothing matches because this first sentence doesn't end in hello, but ends in hello with the period. So we have to add the period. And now you see that we match this hello with the period that is at the end of the string because of this dollar sign. Okay, now let's delete this second hello so we have the sentence as it was in the beginning. And now I want to show you that we can easily match the words hello and world by only writing these words. So for example, if we write hello, we match the word hello in the test string. And if we write the word world, we match the word world here in the test string. So that obviously makes sense. But here, the power of the caret and the dollar sign comes when you have repetitive values in the string. So you only want to match either the words at the beginning or the words at the end, but not the words in the middle. For example, you want to get only the last exclamation mark that is in this second sentence. So if we only write this exclamation mark, we're gonna get only the last exclamation mark and not the others. So if for some reason you want to get only the last element, that's when you can use this dollar symbol, or also the caret symbol when you want to get it at the beginning. And something important I want to mention is that the regular expressions might change slightly their behavior based on some regex flags. So regex flags help us like edit the behavior of these regular expressions, and here in this website you can see it in this site. So you only click here and you will see the regex options. So here I click and now we see all the regex flags. So here we have activated multi-line, and this allows the caret and dollar symbol match start and the end of line. So this means that each line will be taken like a separate text, which means that this is like one text and this is another text. So here we have one beginning of a string and here one end of a string. And here in the second line, we have another beginning of a string and now another end of a string, and so on until the last sentence or the last line. Here also we have the beginning of a string and also the end of a string. So in total, we'll have like 1, 2, 3, 4, 5, 6 beginnings and 6 ends of a string because we have 6 lines. And that happens because we turned on this multi-line. But if we turn it off, so I click here, now we only have one beginning and one end of a string. So the beginning is here in hello and the end is here in 4, 5, 6. So this happens because I turned off this multi-line, so we only have one beginning and one end of the string. And I think this is how Python behaves by default. We're gonna see that later when we go to Jupyter Notebook, but just keep that in mind. You can control these regex flags using a specific method in Python. And that's it. In this video, we learned some meta characters that we can use in regular expressions. Alright, in this video, we're gonna see some quantifiers used in regular expressions. Some of the most common quantifiers in regular expressions are this asterisk, this plus sign, and this question mark. So now let's try them out. First, with the asterisk. So let's say we want to match the number of exclamation marks after the word Python. So here we have the word Python and we have 5 exclamation marks after the word Python. So now let's match some of those exclamation marks using the quantifiers. So first with the asterisk. So first here I write Python and now I write the exclamation mark. So now you see we have only the Python with exclamation mark, so this match because it's exactly the same characters. And now if we use the asterisk, we're gonna see that here the asterisk matches 0 or more characters, and this asterisk will have an effect on the closest character. So if we write here this asterisk, this will count this exclamation mark 0 or more times. So here, as a result, we got that the Python and all the exclamation marks were matched. And this happened because this asterisk match 0 or more characters. So in this case, the character that was evaluated was this exclamation mark, and we count them as many exclamation marks we wrote here in the text. So as a result, we got the Python and the 5 exclamation marks. So now let's see how the plus sign will work. So this plus sign matches 1 or more elements. And I think this will behave similarly to the asterisks. So let's find out. So here I write plus, and now we see that it has the same behavior. So we got here the Python and the 5 exclamation marks. So this plus sign affected this exclamation mark and it captured 1 or more exclamation marks. So here we have 5 exclamation marks and all of them were matched. So as a result, we got Python and all the exclamation marks. And now let's see how the question mark works. So in this case, this question mark matches 0 or 1 character. So in this case, if we write the question mark, we get only 1 because it says 0 or 1. And in this case, there is 1 exclamation mark, and that's why we got only the Python and this first exclamation mark. And now you might be wondering, what does greedy and lazy mean? Because here I wrote in parentheses greedy for the asterisk and for the plus sign, and lazy for the question mark. Okay, first, greedy means match the longest possible string. So it means match as many characters as you can. So for example, here, this asterisk is greedy because it can match 0 or more characters. But here, if we write again the asterisk, we see that it matches the maximum number of characters. So it matched the longest possible string, because here it matched Python with 5 exclamation marks. And the opposite of this is the question mark, because if I write the question mark, it will match the shortest possible string to fulfill my requirement. So in this case, 1 is the minimum number of exclamation marks that will satisfy my regular expression. And also this plus sign is greedy because it behaves the same way the asterisk behaves. So if I write here the plus sign, we'll see that it will match as many characters as it can. Okay, now to understand this much better, we're gonna see a different example. And in this case, we're gonna use the dot sign. And as you might remember, this dot sign matches any character except for new lines. So here, I'm gonna write the word hello. And as you can see, the word hello here in this string was matched. But I don't want to get that. But what I want to do is to get only the words between the H and the L. So to do that, I write here only the H and the L. And now I want to get everything that is in the middle. So here I can use the dot sign, and also I can use the plus sign, because here, if we use the plus sign, we're gonna match 1 or more character. And if we use both the plus and the dot sign together, this means that we're gonna match 1 or more characters except for the new line. So here, if I write plus, we'll see that all the words between H and this L were matched. And this is kind of unexpected, because here I got the words between this H and the L that belongs to the word world. but I didn't want that. I only wanted to get the words between the H and this L that belongs to the word hello. So here we got this behavior because the plus sign is greedy. So it means it will match as many strings it can. So we got the longest string. And in this case, the longest string is this from H to the last L. As a result, the regular expression we wrote here became a greedy regular expression because it matched the longest possible string. And if we want to make this regular expression lazy, in order to get the shortest possible string, we have to convert this greedy expression into a lazy expression. And to do that, we only have to add this question mark. So this question mark converts any greedy regular expression into a lazy regular expression. So let's try this out. I'm gonna add here the question mark after this plus sign. So here I write question mark, and now we see that we got the shortest possible string. So we didn't get from this H to this L. We didn't get from this H to this second L in the word hello, but we only got the characters between the first H and the first L. And this is because we used the question mark, and this is a lazy operator, and it converted this greedy regular expression into a lazy regular expression. So anytime you want to get the shortest possible string, you only have to use a lazy operator like this question mark to convert a greedy regular expression into a lazy regular expression. Okay, now that everything is clear about greedy and lazy matches, now we're going to continue with the quantifiers. So here, the next quantifier we're going to see is these curly braces with a number inside. So this means exact number. So instead of getting 0 or more, or 1 or more, or 0 or 1, now we can specify the exact number of characters that we want to match. So on the left, I'm going to write again the Python with the exclamation mark. And now instead of writing asterisk or the plus sign or the question mark, now I write these curly braces. And now let's say we want to match 3 exclamation marks. So if that's the case, we only have to write the number 3, and we got 3 exclamation marks. So Python and these 3 exclamation marks. And that's how you define the exact number of matches that you want for a specific character. So here you can modify it. So now number 2 and you get 2 exclamation marks, or 5 and you get 5 exclamation marks. So you can set the number you want, and these curly braces will match the exact number of characters that you're indicated inside the curly braces. Okay, now if you want to match more than n characters, so for example, if you want to match more than 3 characters, you only have to write the comma. So here, let's go back to number 3. And now here we match Python and 3 characters. But now let's say that we want more than 3 characters. So we're not sure about how many characters we want to get. We only know that it's 3 or more. So if that's the case, you only write 3 and comma, and voila, you get 5 characters because you specify that you want it more than 3. And this is kind of greedy, so it will match as many characters as it can. And with the next quantifier, you can specify a range of number. So the first element is going to be the minimum number of characters that you wish to match, and the last element is going to be the maximum number of characters that you wish to match. So let's say that we want to match between 3 and 4 characters. So if that's the case, we only write 3, 4, and now we got 4 exclamation marks because it will always try to match as many characters as it can. And that's it. In this video, we learned how to use quantifiers in regular expressions. Okay, now let's see some meta characters that we also use often in Python. So first, we have these parentheses, and this represents groups. So to capture a specific group of characters, we only have to use these parentheses. So now I'm going to show you an example so you understand much better how this works. Okay, for this example, let's create a regular expression that matches these numbers that we have here. So here we have 9 numbers separated by this hyphen. So every 3 numbers we have 1 hyphen. So for this example, we're going to focus only on these 3 sentences. Okay, to do that, we have to use the /d because these are numbers. So we have to match digits. And the meta character that allows us to match digits is this /d. So here I write /d, and now we matched all the numbers. So this is fine, but what if we want to get the first group of 3 numbers? So in that case, we have to use a quantifier. So we have to use the plus operator. So let's write plus, and as you might remember, this plus allows us to match 1 or more character. So in this case, 1 or more digits. And that's why we got kind of the same result. But now if we add the hyphen, we're gonna see that this behaves differently. So now we only got until the last hyphen, but now if we add this /d with a plus sign twice, we'll see something different. So here I paste these ones, and now I add the hyphen, and now I paste this again. So here we have a digit, then hyphen, then digit, and hyphen again, and finally a group of digits. So each /d with a plus sign represents each group of 3 numbers separated by this hyphen. So we built this because we wanted to get only the first 3 numbers. So the first 3 that are here that I'm selecting right now, but I think it's not visible. But anyway, we want to get the first 3 numbers. So now if we want to get the first 3 numbers, now we have to add the parentheses. So this parentheses will help us like capture a group. So if I add parentheses here and parentheses here, we'll see that now the first 3 numbers are in green and the rest are in blue. So that green means that we capture that group, and that's the first group that we capture. So let's capture the second group of numbers, or the second group of digits that are between hyphens. So I add parentheses, and here again parentheses. So now we see that the second capture group is in yellow, and if we add parentheses to the third group, we'll see that this one is in purple. So here we have 3 groups, and we capture those groups by adding parentheses. So here we'll see that it says in this box match 2, but the important thing here is that below it says group 1. So all the matches in green are group 1 because of the parentheses. Then in yellow we have group 2, and then in purple we have group 3. So this is how the parentheses meta character works. And this is an extremely useful meta character when you want to extract certain information from the whole text data. So let's say that you have a data frame and you have a column that has only information about the date. So if you match all the date, you can capture only the years. So if you capture only the years, you can extract those years and create a new column based on that year. Okay, now it's time to see the square brackets meta character. So this meta character matches characters in brackets. So unlike parentheses, square brackets don't capture an expression, but only match anything inside it. So for example, we can write square brackets and inside write the numbers 7, 8, and 9. And we see that all the 7, 8, and 9 digits were matched. So here we have a number 7, and here we have the number 8, and here the number 9. So this doesn't mean that we have the 7, 8, and 9 together, but it means that we match anything that is inside the square bracket. So this is like match 7 or 8 or 9. And instead of writing 7, 8, 9, we can write 7 hyphen 9 and get the same result. So this hyphen means get a range from 7 to 9. So anything that is between 7 and 9 will be included. So if now we write from 5 to 9, so we're gonna get 5, 6, 7, 8, and 9. So all those digits will be matched. And the same goes for letters. So if we write A to Z, we're gonna get all the letters that are in lowercase and that are between the letter A and the letter Z in the alphabet. So here in this string, you see that all the letters in lowercase were matched, but those in uppercase were not matched. And if you want to match the letters in uppercase, you only have to specify here A in uppercase and then hyphen and then Z in uppercase. So here Z in uppercase. So this indicates that we want not only letters in lowercase but also letters in uppercase. And that's how the square brackets work. And now if you add a caret in front of these square brackets, so at the beginning of the square brackets, this will modify the behavior of these square brackets. So when the caret is at the beginning of the square brackets, this means match characters not in brackets. So this is the symbol. So it starts with square brackets, then caret, and then anything that you want to include, and then square brackets. So if we add here, for example, the caret symbol, so this means match anything that is between A to Z in lowercase and in uppercase. And as you can see here, the spaces, the dot sign, the exclamation mark, and the digits were matched. So now if we write the caret and the range from 0 to 9, we're gonna get anything but digits. And this is the result. All the characters in blue are non-digits. And as a final note, keep in mind that the expressions that are inside the square brackets can get really long. And sometimes people get scared because it's hard to understand what this regular expression means. But remember that it doesn't matter how long the regular expression gets, because if it's within square brackets, you can split them as groups. And when you split them as groups, you can think of each group that is separated with an OR condition. So here, for example, if I write 0 to 9, and then I write A to Z, and then A to Z, but in uppercase, so we can separate these characters with the OR condition. So from 0 to 9, or from A to Z in lowercase, or from A to Z in uppercase. And if you want, we can add more and more characters, and it doesn't matter how long it gets. You can split them and add a OR condition in the middle, and you can understand anything inside square brackets in that way. And speaking of OR conditions, let's review how this OR condition works in regular expression. So now I delete this, and to make an OR condition in regular expressions, we have to write this sign. So this is the equivalent of the OR in Python, and it works the same way. So let's see it in action. So here I'm gonna match a string that has 9 or 8 followed by 2 digits. So to do that, we have to write 9 and here the OR and 8. So with this, we match both 9 and 8. And now if we want to get 2 digits that are followed by these 9 or 8 digits, we have to add here the backslash and then the D. And here write these curly braces with the number 2. But now we have to group these 9 or 8. So only these 9 and 8 digits are evaluated by this OR condition, and not 9 with this whole text, because right now this OR operator is evaluating 9 with this 8 and this backslash D, and we don't want that. So we have to group this. So we add parentheses, and here we group this 9 or 8. So now you see that we got the correct match. So we wanted to match a string that has 9 or 8 followed by 2 digits. And we got that. So here we got this 9 or 8 followed by 2 digits. So the text that is highlighted in blue is the matched, and the text that is highlighted in green is the capture group, because we use the parentheses and that's why we capture this group. And in case you don't want to capture a group, you have another alternative. So instead of using parentheses, you can use the square brackets. So here I write square brackets. So this matches a string that has 9 or 8 followed by 2 digits, but now without capturing the number 9 or the number 8. So you see now that the text is highlighted in blue and nothing is highlighted in green because we don't have any capture group. As a side note, I want to remind you that it's not necessary to add the or inside square brackets, because each character that is inside square brackets is split and then evaluated with an OR operator. So if we delete this OR operator, we get only this 9 and 8. Apparently we got 98, but this in reality is 9 or 8. Okay, now let's see what this \b means in regular expression. So this \b symbol is another meta character that matches at the position between a word character, so the /w, and a non-word character, so the slash with the w in uppercase. This is called a word boundary. And now let's see how it works. So here I write \b, and now we see that we have multiple characters matched in purple. So all of them are word boundaries. Okay, and among those purple characters that matched, we have 3 different positions that qualify as word boundaries. So the first position is the position that is before the first character in the string. So this one, that is before the H in hello. Okay, and the second position that qualifies as word boundary is after the last character in a string, if the last character is a word character. And the third position that qualifies as word boundary is between 2 characters in a string, where one is a word character and the other is a non-word character. And a good example of this is the hyphen between the 987 and the 654. So this 7 and this 6 are numbers, so those are word characters, but the hyphen is not a word character, and as a result we got these 2 word boundaries that are in purple. Okay, now as you might expect, this /b has a negation and is /b, but now in uppercase, and this meta character will match no word boundary. So if I write \b in uppercase, now we get all the elements that are not word boundaries. Okay, before finishing this video, let's see how back references work in regular expression. A back reference helps us reuse a capture group we already identified. And now to understand this much better, let's capture this pattern. We're going to capture this 1, 2, 3 with a hyphen to explain you much better how these back references work. So let's write here 1, 2, 3 and a hyphen. So you see here that we matched all the 1, 2, 3 hyphens. So here's the first match, here's the second, and here's the third. But we want to match only repetitive 1, 2, 3. So this means that we want to match this 1, 2, 3 hyphen, 1, 2, 3 hyphen. And all of these should be just one match. So this means that we don't want to match this 1, 2, 3 with hyphen that is alone, because that's not a repetitive 1, 2, 3 with hyphen. So if we want to do that, first we have to capture this 1, 2, 3. So we open parentheses, and in this way we capture this 1, 2, 3. But this is not ready here. We have to use this backslash reference. So we have to add the backslash with the number 1, and this indicates that we want to repeat that reference. And as a result, we got here the 1, 2, 3 and also this 1, 2, 3, and all of this is a single match. So what we did here is to repeat everything that is inside these parentheses. So this is like copying and pasting 1, 2, 3 hyphen here instead of the \1. So if I do this, it will have the same result. So this is the same, but sometimes you don't want to repeat the same expression twice, but you want to use like a shortcut, or you want to reduce a long capture group. And when you want to do that, you only have to use the \1. So that indicates that we want to use the reference that is inside the parentheses. And now if we add another \1, nothing is matched, because now we don't have a sequence of 1, 2, 3 with hyphen 3 times, but only we have a sequence twice. So this and this. But now if I write here, just to show you, I create a new line, and now 1, 2, 3 with hyphen. Now we see that we have this match, and we got this match because now we have a sequence of 1, 2, 3 with hyphen 3 times. And as a result, all of this represents a single match. And that's it. That's how the back references work in regular expression. And now if you have more than one capture group, you can also specify which group you want to reuse by writing its order. So let's say that you don't have one capture group, but two. So instead of this 1, 2, 3 hyphen, we have, let's say 4, 5, 6 hyphen. So in this case, this is my first capture group, and this is my second capture group. So if now we want to reference the second capture group, so 4, 5, 6 with hyphen, we have to write \, and the number 2. So this indicates that we want to reduce this 4, 5, 6 with hyphen, while the \1 still represents the 1, 2, 3 hyphen. So you only have to consider the position of the capture group in this regular expression. Okay, that's it for this video. In the next video, we're gonna see some examples and exercises so we can understand much better all the meta characters we learned so far. Alright, in this video, we're gonna use all the meta characters that we learned so far, but now using Python code. So when we want to use regular expressions in Python, we have to import the RE module. This RE module is a Python built-in package that is used to work with regular expressions. Okay, first we need to import RE to see all the regular expression methods we're going to see in this video. So first we write import RE, then we run, and now we imported this module. And now we're going to see two common methods that are used to match regular expressions. The first one is the search method. And here I have this text variable, and this has the same text that we used in the previous videos. So the same hello world and I love Python and all the same content. So this is the same text. And now let's say that we want to match only the digits. So here we want to return the first digit that is matched in this text. And we can use the search method to do that. So we only have to write re.search, then we open parentheses, and first we need to write the regular expression that matches the digits. So as you might remember, to match digits, we need to write the \, and the D. So this matches digits in a string. And to specify that this is a regular expression and not average text, we have to open quotes. And here, before the quote, we have to write the letter R. So this letter R before the quotes indicates that what we have here is a regular expression. Okay, after this, the second argument is going to be the text we want to evaluate. So in this case, we write the text variable. So I copy and paste it here. And that's everything we need. So let's review this method. First, we write re.search, and the first argument is the regular expression. We indicate that this is a regular expression by writing the R before the quotes. And the second argument is the text we want to evaluate. And that's everything you need. So now I run this, but first I run the text variable. And now I run this, and now we got this that says re.match object, and here we have a match equal to 9. So this means that we only got one match, that was this first number 9. So the search method only finds the first match in the whole text. So even if there are more digits in this text, it won't find all the digits, but only the first digit that appears in the text. So if we check here in Hello World, we don't have any text. In I Love Python, neither. But in the third sentence, we have many digits. And this one starts with 9. So the only digit that is going to be returned is the number 9. And here we got the number 9. And the rest was omitted. Great. Now let's see how flags work when we write Python code. So before, when we were in this website, we saw that here in this option, we got all these flags. So by default, we had the global and the multi-line flag turned on. And here we can control the flags using the flags parameter inside the search method. So let's say we want to get the word hello. So this word that says hello here. So let's use the search method. So we write re.search. Now open parentheses. Now we write the R and here the quotes. So we indicate that what we have here is a regular expression. So now let's say that we want to match anything that starts with hello. But in this case, let's write hello in lowercase. So this is my first argument. And now the second argument is going to be the text, because we want to evaluate this text variable. And in the next argument, we're going to consider the flags parameter. So we write flags and now equal to, and now we have to specify which flag we want to turn on. So here we write re, and let's say we want to ignore the case of the text. So if we want to ignore the case of the text, we have to write here the I, which stands for insensitive. So with this, we won't consider the case of the text. So now if I run, we get that the match is hello. So here, even though this hello is with H in capital letter, we got the match because here we turn on the insensitive flag. However, if we didn't include this flags parameter, so if we only wrote these two arguments, we wouldn't get any match. So as you can see, we didn't get any match because here this hello is in lowercase and here this hello is in uppercase, and that's why we didn't get any match. But with the flags parameter, we got a match because we ignored the case of the text. And by the way, you can see the complete list of flags here in this website that we checked before. So for example, I knew that the I meant insensitive because here the I is highlighted. And if we want to turn on the multi-line flag, we only have to write the M because here the M is highlighted. So here we could write the M, and that indicates that we want to turn on the multi-line. And you can check all the flags in this list here. Okay, now let's see how the find all method works. So unlike the search method, the find all method returns all the matches. So let's find all the digits inside this text. So I'm going to copy this re.search, and now instead of writing re.search, now we're going to write re.find all. So the regular expression is going to be the same, and also the variable. So now if we run this, we see that now we get all the digits inside that text variable. So 987, 654, and so on. So as you can see here, these are the exact numbers that you see here, and they are listed in the order that appear here in this text variable. So it starts with 98 and it ends with 56. So let's check it out. 98 or 9 and 8, and then it ends with 5 and 6. So it's correct, and we got all the matches using the find all method. And that's it. In this video, we learned how the search and the find all method work. Okay, now it's time to put everything we learned so far into practice by solving these 3 exercises. So here are the tasks. First, we have to match only punctuations from this text variable. Then we have to match the right date format. So in this case, the format is month, date, and year. And we have to match the right date format from this text variable. And the last exercise is to match the right username format. And in this case, the right format is from 4 to 14 characters and only letters or digits. So here is the text, and you have to match the right username format. For these exercises, I will recommend you to use the find all method that we learned in the previous videos with all the method characters that we learned in the previous videos too. So try to solve these exercises yourself, and after that, check my solution. Okay, let's start by solving this first exercise, and we have to match only punctuation. So that means that we have to match only this dot sign, here the exclamation marks, and this hyphen, for example. So to do that, first we write re.findAll and then parentheses. Here I already imported the RE module, so you have to do the same. So here the first thing we have to do is to build the regular expression that matches only punctuation. And here we have to analyze what's the best approach. And actually there are many approaches, and I don't think one is much better than other, but maybe one is shorter than other. But what I'm gonna do here is a simple approach, and this consists in using the square brackets. So here I'm gonna write it, and I write square brackets, so this matches any character that is inside. But now if we add the caret, we don't match any character that is inside. So this means match characters not in brackets. So now what I'm gonna write inside these square brackets are meta characters that don't represent punctuation. For example, the \W. This one represents word characters. So as we've seen before, this W represents word characters like the A to Z in lowercase, then A to Z in uppercase, digits from 0 to 9, and also this underscore. And all of them are characters that are not punctuation. So we have a good number of non-punctuation characters there, and another character that is not a punctuation character, and also that is not included here in this \W is this \S. So this \S means a space. So here we have word characters, and here we have a space. So if we now insert this \W and also this \S inside these square brackets followed by this caret, this means match any character that is not a word character and that is not an space. And what it remains is only punctuation, because if you think anything that is not a word character and anything that is not an space is only the punctuation. So let's test it out. And here I copy this regular expression. So now I write the R and then open quotes, and inside I paste this. So this R means that we want to write a regular expression, and what is inside is what we created. So this is match anything that is not a word character and that is not an space. That is match only punctuation. So now the second argument is going to be the text. So this is the text variable that we want to evaluate. And now everything is ready. So we can run this cell. So now I run, and here we have a list of only punctuation signs. For example, the dot sign, the exclamation mark, the hyphen, and so on. Okay, in this second exercise, we have to build a regular expression that matches the right format of a date. And in this case, the right format that I specified is here within parentheses. So it should be month, date, and years. So here, what we have to do first is to write RE, then find all, then parentheses, then we write the R followed by the quotes, and inside we write the regular expression. So let's build this regular expression. So this date format should have these 2 digits followed by this forward slash, and then this again 2 digits, again forward slash, and finally 4 digits. So we can create that using the \d that represents digits. So we write \d, and now this represents digits. But now we have to give it this shape. So first 2 digits. So to do that, we open these curly braces and we write 2. So this indicates that we want only 2 digits. And now I copy this and I paste it twice. So 1 and 2. And the second is \d with number 2 inside curly braces, and that remains the same because we need 2 digits. But the last one should be 4 inside curly braces because the years need 4 numbers or 4 digits. So we write 4, and now we have the format. And now I just realized I made a little mistake here because I wrote this forward slash, but I should have written here a hyphen. So instead of forward slash, we write here hyphen and here hyphen again. And we do that because here in the text we have hyphen between numbers. So it should have the same format. So the final format should be 2 digits, then hyphen, then 2 digits, then hyphen, and finally 4 digits. Okay, now to finish this regular expression, we have to add the hyphen between the digits. So here 1 hyphen and here the other hyphen. And now this is ready. So I cut this and I paste it here. So here we have our regular expression, and now we just have to add the second argument, which is the text. And now if we press Ctrl Enter, we'll see that only the first row, so this one has the right date format because this one has 2 digits, 2 digits, and 4 digits. And the others have 4 digits at the beginning. So these two have wrong date format, and this one has the right date format. And this is why we got here this 13-4-2021. Okay, now let's solve the last exercise. And in this last exercise, we have to match right username format. And the format indicates from 4 to 14 characters and only letters or digits. So here we have the text, and now we start by writing re.findAll to find all the matches. And now here are and quotes, and inside the regular expression. Okay, we have to get only letters or digits, and that indicates that we have to get letters from A to Z or digits from 0 to 9. And to make both of them work together, we have to put it inside square brackets. So as you might remember, these square brackets matches characters inside the brackets, and any group that is inside these square brackets are split and then evaluated with an OR condition. So this means that we'll get here characters from A to Z or characters from 0 to 9. And now if we want to get 4 or 14 characters, we only have to add the quantifier with these curly braces and now indicate 4 as minimum and 14 as maximum. And we separate them with comma. And now this is ready. If you want, we can add also the A and Z in uppercase. So this is like more complete. So this is my regular expression, and now I'm gonna copy and paste this one inside the R with the quotes. Okay, now we only have to add the second argument, which is the text. Now we run, and we got that the only username that matched was this username 10, because it has between 4 and 14 characters, while the others have either 3 or 2 characters. And that's it. I hope you successfully solved these 3 exercises. Okay, in this video, we're gonna see the data frame that we're gonna work with in this project. So the dataset is about Netflix movies and also Netflix TV shows. And here I'm gonna read it. So first I import pandas as PD. And now to read this Netflix dataset, I'm gonna write pd.read underscore CSV. And inside parentheses, I'm going to write the name of the data frame, which is Netflix underscore titles. So this one. So now this is the name of my CSV file. So I read it. Now I run this. And here we get the data frame. I chose this Netflix dataset in purpose because it contains missing data. And also is going to help us apply some data cleaning techniques with pandas. So let's start with the first column, and here we can see the ID, and IDs usually are unique. And here we can see the values. And then the next column here is the type. And here we can see movies and TV shows. Then we have the title of the movie or title of the TV show, the director, the cast, the country, the date, and the release year. And here we're going to use this column a lot to know whether an element of this dataset is actually a movie or not. Then we have the categories of the elements and then the description of the movie or TV show. Okay, now I'm going to name this data frame, and I'm going to name it df underscore Netflix. So this is my data frame. So now I run this. And now let's see the data types of the columns of this Netflix data frame. So to do this, we have to use an attribute that we've seen before in this course. And this is the dtypes attribute. So this attribute allows us to know the data types of each column. So here I'm going to write df underscore Netflix and then dot dtypes. And now I press Ctrl Enter to know the data types of each column. And here we can see that the only integer column we have is the release underscore year. So this means that this is the only column that has numerical data. And that's kind of weird because here the duration and also the date added should have some kind of integer or date format. But here we can see that it has object as data type. So something weird is going on there, and we'll see that in detail in the following videos. But now let's check the shape of the data frame. And by shape, I mean the number of rows and the number of columns that the data frame has. And we can get this by using the shape attribute. So we only have to write df underscore Netflix, so the name of the data frame, followed by dot shape. So this is the shape attribute. And now if I run this, we can see the number of rows, which is the first value here, and the number of columns, which is the second value here. So if we print the data frame df underscore Netflix, we will see that below there is the number of rows and also the number of columns. So we can verify that this is correct. And that's it for now. In the following videos, we will see how to identify missing data and how to deal with missing data. Alright, in this video, we're going to see how to identify missing data. So first, let's have a look again at the Netflix data frame here. So here I write df underscore Netflix, and here we get the dataset. And here it's the dataset, and we can see that there are some NaN values. So this one. So this NaN represents null values. And this means that there is no value here, for example, for this cast in index 0, and also for this director in index 1. So there is no data. And what we can do here is to use the isNull method to recognize them, because here we can easily recognize them because it says NaN, but to check that in the thousands of rows that this data frame has is almost impossible. So we can do it easily with the isNull method. So now I'm going to show you how to do it here. So first we write df underscore Netflix, and now to find the null values we only have to write that is null. So here I write that is null, then I open parentheses, and if I run this, you will see that we get the same data frame, but in this case we get false and true values. So the true values are those NaN values, so null values, and the false values are non-null values. So here we can see that, for example, again, cast index 0, it's true. And this is true because before we saw that this was an ANN value, so a null value. And the same goes for director with index 1. It's the same, it's true because this one is a null value. So here we can recognize all the null values inside a column by using the isNull with the sum method. So here I write that sum, and now what this is gonna do is to sum all the values that are true. So here, for example, here we got some true values. So if we apply this sum method, this is gonna sum all the true values inside this director column. So here we have true, the first true value, and then again another true, so 1 plus 1, 2, then 2 plus 1, in this case we have another true value, so 2 plus 1, 3, so far we have 3 null values, and then it will find true values that represent the null values we've seen before, and it's gonna sum all of them. So in the end we're gonna get the total number of null values per column. So here let's have a look. I'm gonna run this one, and now we see that, for example, the ID column doesn't have any null values. However, the director column has 2,634 null values. And also the cast and country columns have some null values. And it's important to recognize how many null values a column has, because this tells us how our data set is structured. So if a data set has many null values in a column, that means that some columns might be incomplete. So we should think about dropping those columns, so deleting those columns. And for this example, the director, cast, and country columns are good candidates to be deleted. So here I'm going to show you a way to sort first these null values here, because here is sorted according to the original data frame. But now I want to sort these values ascending. So the columns that have the higher number of null values will be on top. So here I'm gonna use the sort values method for that. And here inside parentheses I write ascending, and now I set this equal to false. So now I run this, I get the column with the highest number of null values on top. So in this case is the director column. Okay, as we said before, these 3 columns are good candidates to be deleted, but still we don't have enough evidence or enough reasons to delete these 3 columns, because here we have 2,000 null values, but maybe these 2,000 null values represent a small portion of the total number of rows that the data frame has. So we have to verify the percentage that these null values represent from the total data frame. And to do so, we have to use the min method. So I'm going to show you how to do it here. But first, I'm going to copy the name of the data frame, and now I paste it here. So now I'm going to write the name of any column I want to evaluate. In this case, let's try with the director column. So here I put the name inside quotes, and now I'm going to use again the isNull method. So here, if I run this, we get the true and false values in this column or in this series. So here again, the true values represent null values. And now to get the percentage, we have to use the mean method. So we write that mean. And what this is going to do is to calculate the average number of true values in this series. So it's going to sum all the true values and then divide it by the total number of rows. So in this case, 8,806 rows. So if I run this, we get 0.29. And this represents that 29% of the director column are null values. So this is a good number of null values, and we have to analyze later if we want to delete or drop this column. But first, let's see the percentage of null values of each column. And to do that, we have to use a for loop. So here I write for, then I write column in df underscore Netflix dot column. So here I'm using the columns attribute, and now I'm going to show you how this works in case you forgot. So here I paste it, and this columns attribute should get all the columns that this data frame has. So if I run this, we get a list of all the columns. So from the ID to the description. So all the columns this data frame has. And now this is a list, so we can loop through it. So here in my for loop, I'm looping through this list. So here I'm saying for each column in this list of columns, do this. So execute this line of code. So instead of writing here the director column, we have to introduce the column variable here. So in this way, we're going to iterate through all the columns that this Netflix data frame has. So we're going to get the percentage of all these columns. So the percentage of null values. So here, now to show you this, I'm going to here assign a name for this percentage. So I'm going to name it percentage. And now I'm going to print this one. So I write print. And now I want to show the percentage of each column. So here, print percentage. Now I run this, and now we get the numbers. And the column that has the highest percentage of null values is this one, with 29% of null values. But we don't know which column corresponds to this value because it doesn't say anything. So we have to print the column variable. So here I write column and then plus to concatenate these two variables. And now since this percentage variable is a number, we have first to convert this into a string. So we write here str, and now we convert this number or this integer into a string. So now I think everything is fine. So I'm going to run this one. And here we see the name of the column and the percentage. So I'm going to add a column in the middle so we can see clearly the name of the column and also the percentage. So here I open these quotes and now the column symbol. So here I do this and now run. And now we can see clearly the name of the columns and also the percentages of null values. So here the column that has 29% of null values is the director column, as you can see here. So we can now even customize these numbers. So we can write here in percentage, multiply here with 100 and then round this number, and we want 2 decimals. So I'm gonna write 2 decimals here comma, and here 2 decimals. So if I run this, we get the same values, but now in percentages and with 2 decimals. And that's it. In this video, we learned how to identify missing data. And in the next video, we're going to decide whether these columns that have a good number of null values are gonna be deleted. Alright, in this video, we're gonna see how to deal with missing data. So in the previous video, we identified some columns that have a good number of null values. For example, this director column has 29% of null data. And here we're gonna decide whether we're gonna delete or drop those columns, or maybe if it's a better idea to drop rows. So to drop those null values inside those rows. So let's see what's the best solution for this case. So here I'm going to use 3 different methods, and these are the drop NA, and the isNull methods. Some of them we already seen in this course, but some of them we haven't seen so far. But don't worry, because I'm going to explain you how they work from scratch. So here first, let's say that we want to drop this director column because we consider it has a good amount of null data. So here, if we want to do that, we have to use the drop method, and we only have to write the name of the data frame, so df underscore Netflix, and then we have to write that drop, then we open parentheses, and inside we have to specify the name of the column we want to drop. So in this case is the director column because it has too much null data. So here I write director, and now here, as you might remember, we have to specify the access. So here we say access equal to 1, and we write equal to 1 because this is a column. So column is 1 and row is 0. So here we're saying drop this director column. So now it's ready and we can run this one. So I run, and now we get a copy of the data frame. In this case, this data frame doesn't have the director column. So we successfully deleted this director column. But here I'm not going to take this approach because the director column might have some important data that we might use later. So it's not a good approach to drop the whole column because it can contain some important data. So sometimes it's much better if you can get rid of the specific rows that contain that null data. And that's what we're gonna do right now. So here I'm gonna write df underscore Netflix, and now I'm gonna find which rows are null. So here I'm gonna write here director. So this is the director series, and now I use the isNull method. So here I'm gonna get the null values inside the director series, and what we're gonna do now is to filter this based on this condition. So here is my condition, so get the null values, and now I'm gonna filter this. So with this we get the data frame with null values, and if now I write that index, this index is my attribute that gets the index of this data frame. And in this case, this data frame contains only null values. So this means that we're gonna get the indexes that correspond to those null values. So here I'm gonna run this one. So I comment this out and I run. And as you can see here, I got here a list of indexes, and it says 1, 3, 4, and so on. And these numbers represent the indexes that have null values inside the director column. So now let me show you here in the real data frame, df underscore Netflix. So now I run this one, and as you can see here in the director column, the null values are in row 1 or index 1, then row 3 or index 3, here we have NAN, and then also in index 4, NAN again. So we should get 1, 3, and 4 because those indexes contain null values inside the director column. So now let's verify if that's true. So here we got 1, 3, 4, and so on. So all these elements inside this list are indexes that correspond to null values inside the director column. So here I'm gonna name this as no underscore director, which means that the values inside this expression are null, so they don't have a director value. So no underscore director. And now I'm gonna drop these indexes because, as you might remember, these are a list of indexes that are right here. And now I'm gonna drop those indexes. So what I'm gonna do is write the name of the data frame as I did here. So actually I'm gonna copy this one so I have this to edit. So here, instead of writing the name of the column director, I'm gonna write the variable no underscore director. So here I paste it, and now instead of saying axis equal to 1, I have to change this to axis equal to 0, because 0 represents rows or indexes. And here we have a list of indexes. So now everything is ready. And now let's run this one. I'm gonna comment this out and I run. And here we got this data frame. And as you can see here in the indexes, we have 0, but then we don't have 1 because we removed or we dropped that index. Then we have 2, and then we have 5, but 3 and 4 are not here because those rows contain null values inside the director column. So that's why we dropped it. And now we can easily verify how many null values are in the director column using the same method we used in the previous video. So here, what I can do is to write is null, and then parentheses, and then sum, and parentheses. So now let me show you here. I run this, and here I go to the director column, and as you can see here, it says 0, which means that this column right now doesn't have any null value. And this is because here we drop all the null indexes using the drop method and this no underscore director list. So now I'm gonna get rid of this, and here we have the data frame without null values in the director column. And that's it. I consider this a better method to deal with missing data. So I will add here an in place equal to true. So you can add this one so you save all the changes we made with the drop method and you update the values in the df underscore Netflix data frame. But I'm not gonna do that because I need these null values to make the following examples. So I'm not doing that only for the sake of this video. But you should do it if you want, because that's a better approach than dropping the whole column as we did with this line of code. So not this one, but we're gonna take this approach. So this one is much better. But in my case, I'm not going to add the in place parameter. So here I delete it. And now let's continue with the following example. So here I want to show you how to do the same thing. So how to drop rows, but now only with the isNull method. So here before we used the isNull method with the drop method to drop these rows, but now I'm going to use the isNull method with the not operator. So let me show you how to do it here. So here I have to write first the name of the data frame, which is df underscore Netflix, and then we open square brackets. And actually we're gonna do this filter is exactly the same as we did before. So I copy this one and I paste it here inside square brackets. So now instead of getting the index as we did before, we're gonna use the not operator. So here I'm gonna add parentheses, and outside parentheses I'm gonna add the not operator, so this one. So here inside parentheses I'm saying I want to get the null values inside the director column, But now, when we use the not operator, we're saying, hey, I don't want the null values, but I want the non-null values. So here, by using the not operator, we get the non-null values, and after this, we get the filter, and we get the data frame with non-null values. So it's like we're dropping the null values in the rows. So it's like we were doing this part, but in this case, we're just doing it with the not operator. So if I run this one, let me show you what happens. So I comment this out and now I run. And here we can see that index 1 is not here, index 3 and 4 is not here. And now if I use the here the is null and then sum to get the number of null rows, we're gonna get that the director column doesn't have any null value. So now I'm gonna delete this one. And as you can see here, the is null with the not operator does a similar job as this is null with the drop method. Okay, finally, I'm gonna show you a third way to drop null values, but in this case, we're gonna use the drop NA method. And this is the simplest method, and I'm gonna show you here. First, we write the name of the data frame, followed by the drop NA method. So we open parentheses, and now we have to specify the column in which we want to analyze whether there are null values or not. So here I write the name of the column. So in this case, it's gonna be the director column. And here I'm gonna add these square brackets and also add a parameter called subset. So here I write subset equal to, and this is the column that I want to analyze. So we do this because that's the syntax of the drop NA method. So we have to write a subset parameter, then equal to, and then open these square brackets. So if this director column has null values, we're gonna drop those null values by using this drop NA method. So now let's check it out. I'm gonna comment this out and these two out. And now I run this, and here we can see that we don't have this 1 index and 3 and 4 are gone too. So now fast I verify the number of rows that are null values. So here is null sum. And here we can see again that the director column doesn't have any null values. And that's it. In this video, we learned different ways to remove a column or row with the drop NA or is null method. And also we learned best practices to deal with missing data in pandas. In this video, we're gonna see how to deal with missing data by using the fill NA method. Okay, instead of dropping rows and columns as we did in the previous video, we can deal with missing data by using the fill NA method, and we can replace the null values by the mean or the median or the mode. And I'm going to show you how to do it now. So the first thing you have to do is to calculate either the mean, the median or the mode of the column that we want to replace its null values. So here, let's say we want to evaluate the rating column. So this rating column has some null values. So we want to replace the null values inside this column for the median or the mean, for example. So what we have to do is to write df underscore Netflix, which is the name of the data frame, open square brackets, and here we write the name of the column. So we write rating. This is the column that we want to evaluate. So now to calculate the mode, let's use the mode in this example. So to calculate it, we have to write mode and then parentheses. So this is a method and it helps us calculate the mode of this rating column. So let's see what's the mode of this rating column. So here I run. And by the way, the mode is the most common value inside a group of elements. And in this case, this TV-MA is the most common value inside the rating column. So here we can use this value to replace the null values. And this practice that sometimes people use, because if this value is already common, is already popular, it's not going to affect the end result. There are already many values that have TV-MA. So if we replace the null values by the mode, at least it shouldn't affect so much the result. So here, what I'm gonna do now is to assign this value to the null values. And to do that, I'm gonna use the fill_NA method. So what I'm gonna do here is to, again, write the name of the column. And now I'm gonna write the fill_NA method. So I write dot fill_NA and then open parentheses. And here, the argument that we have to introduce is the mode, so this one. But now I wanna show you something before we do this fill_NA method. This mode value, as you can see here, is not a string, is not an integer, is some kind of array or some series. I mean, if you see the data type, it says object. So if we add this value as it is to the fill_NA method, we're gonna get an error because this fill_NA method expects some kind of integer or string. So what we have to do here is to convert this object, and actually I think this is a series because it has this format, the value and the index. So we have to convert this into a string so we can add it to this fill_NA method. So that's an argument, and then it's going to replace the null values here. So to do that, I'm going to use the join method, and this join method allows us to join strings. And in this case, I'm going to use it to convert this value into a string. So what I'm going to do here is to add parentheses and now add here dot join. And this join method is going to join all the elements inside parentheses. So here, since we only have one element, we're going to get the same element but in string format. So the final format of this is going to be a string. And now we only need to add the separator. So I only open quotes. So in this way, this value inside the join method is going to be the same as the one we introduced. So this TV-MA is going to remain the same, but now the data type will be a string. So now let's try this out. I'm going to assign this to a variable, which I'm going to name mode. So this is my mode variable. And now let's see the data type of this mode. So here, I'm going to use the type function and now use parentheses, run this one. And as you can see, it says str, which means that this now is a string. And now we can add it to the fill_NA method. So we now copy this mode and we paste it here. So now we have the mode, and now we can replace these null values by the mode. So now I'm going to add the in-place parameter, and I'm going to set it to true to update the values in this df_Netflix data frame. So now before I run this code, I want to show you fast how this rating column looks. So here, this is the data frame and the rating is this one. So let's see how many null values this rating column has. And to find the null values, we have to use the isNull method. But first we write the name of this column, and then we use isNull with parentheses. And now to filter this, I'm gonna insert this inside square brackets. So now I run, and now we get the rows that have null values and the rating column. So this one, these three, and this one. So we only have 4 rows with null values in the rating column. And what we're going to do is to replace these NaN values by the mode. So now I don't need this, and let's do this here. So now everything is ready, and I'm gonna run this one. So here I run, and now let's see how many null values this rating column has. So as you might remember, we only need to use the isNull and the min methods. So first I delete this. Now I write is null, parentheses, and then that mean with parentheses. So now I run this, and here we get the columns and also the null values here on the right. So now we look for the column named rating, and it's here, and we get 0. So it means that this column doesn't have any null values anymore. So we successfully replace the null values by the mode. Now I delete this, and by the way, you can use the mean or the median, but in this case I chose the mode because this rating column, I'm going to show you here, this rating column has text. So here all these values are text. So this is known as categorical data, and when we have categorical data we have to replace null values by the mode. But when we have numeric data, like the column, for example here, the year, the release underscore year, that's numbers, so that's numeric data. There we have to replace null values by the mean or the median. So in this case, for example, let's say this rating column has numbers, and we will use either the mean or the median. But in this case, this one is categorical, so here we use the mode. So just keep that in mind. Okay, now I'm going to show you how to replace null values by an arbitrary number. So sometimes instead of replacing null values by the mean or the median, we use an arbitrary number and we replace null values with this arbitrary number. Usually this number won't affect the final result, but it helps us work with the column as if all the values inside the column were non-null. And this is useful because when sometimes you have null values in a column with numeric data, you won't be able to do some operations because those null values won't allow you. So now I'm going to show you how to do this. And as usual, we write first the name of the column. In this case, I'm going to use a column with numeric data, and this one is going to be the duration. So here I write duration, and before we apply the fill NA method, I'm going to show you how this one looks. So here we got this column, and you can see that it has a mix of numbers and text. So we can see that this column isn't numeric at all, but it has some numbers. And I'm going to add the number 0 to this column because in the next videos, we're going to use some operations to split this data. So we get in one column only the numbers and in the other column only the text. And I'm going to show you how to do this, but in the next videos. But now I need the number 0 because if I have null data in this column, I won't be able to do this split. So that's why I'm going to replace null values by the number 0. So now I write here dot fill NA open parentheses, and the first thing we have to write is the arbitrary number. So in this case 0, I want to add number 0, and now I just write in place equal to true, and that's it. With this we replace the null values by this number 0. So I run this one now. Okay, now I'm going to show you a parameter that allows us to fill null values backwards and forwards. And first we have to write this one again. Actually, I'm going to copy all of this, and now I'm going to paste it here. So now I'm going to delete this, what is inside. And now instead of using the mean, the median, an arbitrary number, or any other thing we've seen so far, we're going to use the forward or the backward non-null value to replace any null value. So to do that, I'm going to add the method parameter. So here, this method parameter has two options. So the first option that we're going to see is the backward option. So if I add this one, the null value will be replaced by the non-null value that follows it. So the one that is in the next position. So I'm going to show you here with an example. So I'm going to print the df underscore Netflix. And here we have the data frame, and let's find the director column, and here we see one null value. So if we apply the fill innate method with the backward option, what we're gonna get is that this director, Julien Leclerc, will replace this null value. So it's gonna replace backwards. The non-null value, Julien Leclerc, will replace the null value backwards. But now, if we use the same method, but now in the second option, forward, so here I write it, what we're gonna get is that the first director here, Kirsten Johnson, is gonna replace this null value forward. So this non-null value will replace this null value forward. Okay, and now that this is clear, I'm gonna show you the true names of this method. So instead of writing backward, this one is called bfill, so backward fill, and this one is called ffill, so forward fill. And these are the names. And now I'm gonna apply this to the whole data frame. So not only to the director column, but to the whole data frame. So now I delete this one, and also I delete this one. So with this, all the columns will be affected by this bfill or ffill. So let's try first with the backward fill. So now I run this one, and we see that this director, Julien Leclerc, replaced this null value, or this former null value, because now it has the value of Julien Leclerc. And now let's try with the method ffill. So it's going to be the forward fill, and now I run, and now it's different. So we see that this former null value is now Kirsten Johnson. So this director here replaced this former null value, and it was a forward fill. This is usually used when we have a sequence of values in a column. So for example, if we have the data of the weather every minute in a city, and for some reason we don't have a data of one specific minute, we can either forward fill or backward fill, because the weather shouldn't change so much in 1 minute. So in this case, it makes sense a lot to backward fill or forward fill. But in some other cases, it wouldn't make so much sense. So it depends on the data. So in some cases, maybe it's much better to fill with the median or the mode or the mean, or just drop the column or the row, as we've seen in the previous video. And that's it. In this video, we learned different ways to deal with missing data. Remember that each dataset is different. So you have to analyze your dataset and take the approach that fits best your data. Alright, in this video, we're going to learn how to extract data from a column. And in this case, we're going to extract data from the duration column using the split and extract methods. So first, I'm going to select the duration column. So I write the name of the data frame, df_Netflix, and then the name of the column, so duration. Now I run this, and now we can see that this data has the duration of movies and TV shows. So here we can see that durations of movies is in minutes, but the duration of TV shows is in seasons. So we have 2 seasons and 3 seasons and so on. So here we're gonna analyze only the movies, because we only want to compare in the following videos movies with minutes. So our unit of measure will be minutes, and we only need movies for this purpose. So what we're gonna do now is to filter out TV shows. So we do this with the methods we learned in previous videos. So we write first df_Netflix, then we write here the type of this show. So if it's a movie, it's gonna be in this data frame, but if it's TV show, it's not gonna be in this data frame. So we're gonna filter out TV shows. So here I write the name of this column, which is type. So here type, then equal to, and now I write only movie. So here copy and paste movie. So now we only want movie, and this is our condition, and here we put it inside square brackets. And now I'm gonna set this as a new data frame, and I'm gonna name it df_movie. So this is my new data frame. And now I'm gonna choose this data frame to make the selection. So now I paste this, and now let's select this duration column from the DF movie data frame. So now I run this, and as you can see here, we only get the duration of movies. And here we got the unit of measure, which is minutes. And this is great because now we can make a better comparison because all of them are in minutes. But this still isn't complete because here we have numbers and text. So to compare, we only need numbers because we compare one number with another number. But we cannot say that one element is greater or less than other with text. So here we have to extract only the numbers. And this is what we're gonna do using the split and the extract methods. So first, let's have a look at the split method. And to use the split method, we have first to get access to the str attribute. So as you might remember, this str stands for string, and this helps to work with string data inside this column. Okay, now that we have the string of this duration column, because we use the str attribute, we now can use the split method. So I write .split, and by default, the split method splits this data every time it encounters a blank space. So here, between the number and the text, we have a blank space. So every time it finds a blank space, it's gonna split this whole text or this data. So now I'm gonna run this one and you're gonna see the results. So here we get a list, and inside this list we have all the elements that were split. So here we see that we have the numbers on the left and we have the text on the right. So here the text is minutes, and this is not so relevant, so we're going to select only the numbers, so the first element in the list. And one parameter that is used frequently in this split method is the expand parameter. So I write it here, and this parameter allows us to expand this list into columns. So if we have here two elements, if we write here expand equal to true, we're gonna get two columns, and each column will contain an element of this list. So column number 1 will contain only the numbers, and column number 2 will contain only this text that says minutes. So here I run this, and as you can see, we have this data frame with 0 and 1 as columns, and here in the column 0 it says 90, 91 and only numbers, and here in the column 1 it only says minute. And that's what we wanted. Now we can select only the 0 column by using square brackets and writing the name of the column. So now I write 0, and now if I run this, we get only the column with the numbers. So here we have the duration in minutes, but now only the numbers. Great, so far so good. But here there is a little detail. We see that all the data here are numbers, but here below we see that the data type here in this dType attribute is object. And this is a bit weird because all of the data that we see here are numbers. So we have to convert this data in this series into integers. So what we have to do here is to use the asType method. So we write asType, and this method allows us to convert from one data type to another. So here inside I write int, and this stands for integer. So now I'm going to convert this data, which is object, into an integer. So now I run this, and let's see the results. And I got an error, so let's see what happened. Now I scroll down and I'm going to read the error, and it says cannot convert float NaN to integer. So this means that there are null values inside this column. So that's why it cannot convert to integer. And that's a bit weird because in the previous videos, we replaced the null values inside this duration column by an arbitrary number. And if I'm not wrong, that number was 0. Yeah, it's here. So we replaced all the null values inside the duration column by the number 0 here. And then we updated with this in place equal to true. So what's going on? So there is a simple explanation to this. Here, when we use the fillNA method to replace null values inside the duration column by this 0 number, we set this 0 number, which is an integer. But here below, you can see that here when we call this column, this duration column, we're getting access to the string data type inside this column. And here there is a conflict because here we're expecting strings, but here we added integers. So this is why when we use the split method here, it doesn't find any string when we get to the rows that have these 0 values. So when it gets to those rows, it will detect some null values. So here, when it makes the split, we get null values as a result too. So that's why when we use the asType method here to convert this data into integers, we get this error because it says that there are null values, and of course we cannot convert null values into integers. So here a simple solution is just to modify here what we added. So instead of adding this 0 as integer, we add this 0 as a string. And to do that, we only have to add these quotes, and that's it. Now this 0 is a string. And when we get access to this string attribute, this time we're gonna get the 0 because now 0 is a string. And then we're gonna split this successfully. So now let's try this out. I'm gonna update this change, and to do that, I'm gonna click in this option that says cell, and then click on the option that says run all above. And I wanna do this because I wanna start from scratch so all the changes are properly executed. So now I click on run all above. Okay, after running all the cells above, I'm gonna run this cell. So before I run the cells from the beginning to this one. So now I'm gonna run this one to update these changes too. So I run this, and now we should get this 0 integer instead of the null values. So now I scroll down, and now let's run this code and let's see if everything is fine now. So now I run, and as you can see here, I don't get any error. So now we got this series, and now this data type is integer. So everything is fine now. Okay, in the following videos, we're gonna use this column. So I'm gonna give it a name. So here, I'm gonna write df_movie. And now I'm gonna give it a name. So I'm gonna name it minute. And probably if we assign it this way, we're gonna get a warning message. And it's gonna be fine. So I'm gonna show you here. Here, you see that we got this setting with copy warning, and warnings are not errors. They just let us know that something is going on and that we should check it out, but it doesn't mean that we did something wrong. It's just a warning. So you can even turn off these warnings, but I don't recommend you because sometimes they are really useful. By the way, we could avoid this warning by using the assign method, but in this case, I wanted to simplify this and make this simple assignment, and it's fine. We don't have to worry about the warning. So now let's continue, and I'm going to show you how this data frame looks. So here I print this df_movie, and now the last column should be this minute column that you see here, and now we only have numeric data inside this column. So it's great. Now if we check the data type, we see that the minute column is integer. So it's great. That's what we wanted. So as I said before, we're going to use this minute column to do some analysis in the following videos. But now I want to continue with the split method because it has some other parameters that could be really useful when working with data. So now in this case, let's work with a different column. So now let's work with this date_added column. And this date_added column has some patterns. As you can see here, it has the name of the month, then it has the number of the day and the year. So here we could split this date by the comma. So here, if I write df_movie and then we write the name of the column here, and then .str to get to the string data, and now that split. We can use a separator. So here before we didn't add a separator because we wanted to separate by the default blank space. But here we want to separate by a comma. So we write here split, and now I write comma inside these quotes. So if we do this, let's see what happens. So now I run, and as you can see here, we got a list, and inside the list we have two elements, and the two elements were separated by the comma. So we have the year here, and we have the month and the day. And we can even add the expand parameter to create two columns here. So I write expand equal to true, and now we see that we have two columns. And now if I select column number 1, we get only the years. Great. Now I'm going to show you how the extract method works. And this is a similar method, but it has some differences. So here I'm gonna delete this. And now to use the extract method, first we have to get access to the string. So here we write .str, and after this we write extract. So here extract, then parentheses, and inside we have to write the element that we want to extract. So for example, if you want to extract only the commas, you have to write quotes and then write the comma. And here, the only thing that you have to add is parentheses, because when we use the extract method, we have to add capture groups, and the capture groups are represented with parentheses. So here I add parentheses, and now we can extract only the commas. So here you can see that only the commas were extracted. But the extract method is really powerful when we use it with regular expressions. If you never heard of regular expressions, they are expressions that help us extract data from a text based on some patterns. So here I'm going to show you a pattern that extracts only the years. And the years only has 4 digits, right? So we can write the digit symbol that is represented by this backslash and the D. So this in regular expression represents the digit symbol. So now if we want 4-digit symbol like years have, we have to add these curly braces and write the number 4. And this in regular expression means that we want 4 digits together. And that's what the years represent, because the years are 4 numbers that are together. So I'm going to show you here, and here we have it again. A year is made of 4 numbers that are together. And this is different from the day, because a day has only 2 numbers. So here I'm going to do this. I'm going to get these 4 digits together that represent the year. And before I run this code, I'm going to add these parentheses, because as I told you before, when we use the extract method, we need to capture groups with parentheses. So now I run this, and here I got a column with only the years. So 2021, 2016, 2019, and so on. And we got here this because we use this regular expression that represents 4 numbers together. And by the way, you can even use regular expressions in this split method. You only have to add it here inside quotes. And that's it. In this video, we learned how to extract data using the split and extract methods. Remember that in the following videos, we're going to use this minute column that we created in this video to identify outliers. Okay, in this video, we're going to learn how to identify outliers. And we're going to use histograms to identify outliers within numerical data. So here, first, we're going to make a histogram from the minute column we created in the previous video. So I'm going to show you this column. So I write df_movie, and now I write the name of this column we created before. So it's this one. So this column has this numerical data that represent the duration of a movie. And now we can identify outliers inside this column. And in case you don't know what's an outlier, outliers are uncommon elements that you will see in a group of data. So for example, in a movie, movies usually last between 1 hour and 2 hours. And if you find a movie that has like 30 minutes of duration, or a movie that has like 4 hours of duration, that's extremely uncommon. So those type of movies will be considered outliers. And the criteria to select outliers will depend a lot on your data set. Okay, now let's find these outliers inside this minute column by using histograms. So we're gonna use the plot method that we learned in previous videos. So this plot method helps us make visualizations in pandas. So here we need to add the kind parameter, and here we have to set it equal to hist to make a histogram. Now I'm gonna add the bins parameter to specify how many bins this histogram will have. And in this case, I'm gonna set it to 10 bins. So now it's ready. So I run this, and here we get this histogram. So here is easy to recognize that the outliers are here in the first bar and in these tiny bars that you can barely see from 200 to 300. And you can say that those are outliers because those bars have almost no values inside. So only a small proportion of the data are in those ranges. So if there are little data in those ranges, we can say that the data that is there are outliers. Okay, so we know that here in the first bar and in the last two bars, we have outliers. But now it'll be great if we can recognize the ranges. So here in the first bar, we know that it starts with 0, but we don't know what's the value that this range ends because it doesn't say anything here in the x-axis. So we can get these values here that should be here with the value counts method. So let me show you here. So apart from getting this nice visualization and recognizing where the outliers are, we can get also the ranges. So here, if I write df underscore movie and now here minute, and now I use the value underscore count, we can see the values of the ranges. So we only need to add the bins. So here bins, and this one has to be exactly the same as the number of bins we added here in the histogram. So here in the histogram, I added 10 bins. So here in the value counts, I also have to add 10 bins. And after this, I run, and here you can see that we get the ranges here in the indexes, but it's not properly sorted. So here I'm going to use the sort index method to sort the indexes. So here I run this, and now we sort this ascending. So here we got the first range, which represents this first bar that I'm pointing now, and here the last two ranges represent these tiny bars that you can barely see here. So we can say that in this dataset, outliers are movies with duration less than 31 minutes or with more than 249 minutes. However, if you start analyzing this dataset a bit more, you will notice that you can expand the range of the outliers. For example, here we can say that this range from 218 to 249 can be also considered outliers because here we only have 6, and it's only 6 movies from thousands of movies in this dataset, so it's a tiny proportion. So again, this depends a lot on your criteria and also on the dataset you're working with. Okay, after you decide which ranges are considered outliers for you, you can filter them out. So we only have to use conditions as we learned in previous lessons. So here, let me show you. So let's say that the first range is an outlier and also the last 3 ranges. So to filter them out, we only have to write this df underscore Netflix, then we write here square brackets, and now minute. So here I'm going to compare this column with the value 31. So I write 31 here. And now this is my first condition. So now my second condition is going to be this less than 218. So I write it here. And now I have my second condition. So here I add parentheses to condition number 1 and also to condition number 2. And now I add this AND operator. And to filter these two conditions, I add the name of the data frame and also square brackets. So here, if I run this, and here I got an error because I wrote df underscore Netflix, but here it should be df underscore movie. So my bad here. So I just replace df underscore Netflix and write df underscore movie. And now I run this and now everything is fine. So here we can see that this data frame only contains movies with duration greater than 31 minutes and less than 218 minutes. So now let's check the last column, and here we can see 90 minutes, 91, 125, and yeah, it's fine. So we filter the outliers out. And now in case you want to see the outliers, I can use the not operator here with parentheses and now the not operator to print the data frame with the outliers. So now I run, and here we have this data frame with only outliers. So let's have a look at the last column, and here we have a movie with 23 minutes, 13 minutes, 229 minutes, and so on. So these are the outliers, and before we filter them out. Okay, now we're going to identify outliers with box plots. So another way to identify outliers within numeric data is using box plots. And a box plot let us see how the values in a data frame are spread out, and we can use it to recognize outliers. So now I'm going to show you how to do it. So first we have to write the name of the data frame, and then we write the name of the column, so minute. Then we have to write the plot method to make this box plot, and after this we write the kind parameter and write here equal to and here box. And this is how we make the box plot. So now I run this, and as you can see here, we have here the box plot, and all those dots that you see here are the outliers, and all the values that is inside these whiskers that this box plot has is the range where the data will be usually located. So here now I'm gonna customize this box plot, and I'm gonna add some parameters. So here, to see this box plot much better, I'm gonna add the vert parameter and set this equal to false. So this one will allow me to put this box plot in vertical position. Now I'm gonna add another parameter, in this case the color parameter, and I'm gonna set this box plot to the blue color. And finally I add the fixed size parameter just to make this plot bigger. So I set this equal to 10,5, and that's it. Now I run, and we can see this box plot much better. So here on the x-axis we have the minutes. So this is the duration of the movies. And here these values that are dots and that are outside the whiskers of the box plot are outliers. So this box plot is telling us which values are outliers. And by looking at this box plot, we can see that the outliers are less than 48 approximately, and also the outliers on the right are greater than 155. But that's only a guess because I don't know exactly what are those values. I just know that it's close to 50 on the left, and on the right is close to 150. But to find these values, we can use some formulas that I have here. So here we can use some formulas to calculate the range where the outliers are located. So here first we have the IQR, and this IQR is the Q3 minus the Q1. And as you might remember from previous lessons, this Q3 is the top of this box and the Q1 is the bottom of this box. So here we can use the describe method to get these Q3 and Q1 values. And with this, we can calculate the IQR. And with the IQR, we can use these two formulas I have here. And this will help me calculate the ranges where the outliers are. So the first formula represents the minimum value of the whiskers, so this one that is in blue, and the second formula represents the maximum value of the whiskers, so this one that is here, and both can help me find what are the ranges of the outliers. So here I'm gonna find the Q3 and Q1 of this box plot, and to do that I only have to use the describe method. So here I write the name of the data frame, then the name of the column I want to analyze, so minute, and now describe. We've seen this method before, and this method gives some descriptive statistics, and we can see it here. So here the 25% represents the Q1 and the 75% represents the Q3. So here Q1 is 87 and Q3 is 114. So with these values now we can replace in this first formula to calculate the minimum value of the whiskers. So here instead of Q1 we can write 87 here, and then minus 1.5, then multiply with this IQR, and the IQR is Q3 minus Q1. So Q3 is 114 and Q1 here again 87. So here we have this value, and I'm gonna name it this min underscore box plot. So this is the minimum value of the whiskers or the box plot, and now I'm gonna copy this one and paste it right here. So now I'm gonna replace this with the second formula. So Q3 is 114 and then plus 1.5 times, and this 114 minus 87, which represents the IQR. So here we have the first and the second formula, but here I have to change the name. So in this case, max underscore box plot. All right, with this, we calculate the mean and the max values of this box plot. So now I'm gonna show these values. So here I comment this out, and now I print both values. So here the first one and now the second one, so max underscore box plot. So if I run this, we get the minimum and the maximum value of the whiskers. So here the first is 46.5, and this should be this minimum value of the whisker here, and the maximum is 154, so this one. Now that we have these values, we can say that in this dataset, the outliers are movies that have a duration of 46 minutes or less, and movies that have a duration of 154 minutes or more. And such movies are represented by the dots that you can see here outside the whiskers of this box plot. And now we can filter out these outliers as we did previously with the histogram. So what we have to do is to copy this condition and now just modify the values. So here I paste it here, and now I write instead of 31, 46, and here 154. So these are my new limits for the outliers. And as I told you before, this criteria to select outliers depends a lot on your dataset and also on the project that you're working with. So it depends a lot on the goals of your project. So in this case, if I want to filter outliers using the data that I saw in the box plot, I will write these values 46 and 154. So now I run this, and here we get the outliers because I'm using here the not operator, and here we see 161 and 166. So these movies are outliers because these values are uncommon. And that's how you use a box plot to identify outliers within numeric data. Okay, now we're gonna see how to use bars to identify outliers within categorical data. So here, when we have to find outliers within categorical data, so data that has many categories, we cannot use histograms or box plots because that's for numeric data, but we have to use bar plots. And here I'm going to show you how categorical data looks, and here I'm going to print the column rating. So here, this rating column has categorical data here, and here we can see that we don't have numbers, but we have categories. And you can see all the categories by using the value count method. So here I write value underscore count, parentheses, and here we get all the categories. So for example, the TV-MA rating is the category that has the highest number of values. And here these three last categories, 84 min, 66, and 74, are probably outliers because we only have one value in these categories. So we can say that these three last categories are uncommon and for that reason outliers. But now we can see this much better in a plot. So I'm going to use the plot method. So I write dot plot, now parentheses, so I add the kind parameter, and here bar. Then I add another parameter to make the plot bigger, in this case fixed size, and I'm going to set this to 10,5. Then I run this, and now it's evident that the last 6 categories in this bar plot are outliers because we can barely see the bars that these 6 categories have, and that indicates that those categories are uncommon. In contrast, this TV-MA category has the highest number of values, and we can see this because it has the tallest bar. And now that we recognize these outliers, we can filter them out using the conditions. So in this case, we could use a condition that says that ratings is different from a list, and that list is made of these 6 categories. And by doing that, we filter them out of the df underscore movie data frame. In this case, I'm not going to do that because it's the same as we did in the histogram and in the box plot, but you can do it as an exercise. And that's it. In this video, we learned how to identify outliers using bar plots, box plots, and histograms. And also we learned how to deal with these outliers in pandas. Alright, in this video, we're going to learn how to deal with inconsistent capitalization using the lower, upper, and tidal methods. This will help us standardize the letters that are in one column. So we can set all the letters to uppercase, to lowercase, or to tidal case. So let's try this with the title column, and I'm going to show you this one. So here I write df underscore movie, then open square brackets, and here title. Here we can see the titles of the Netflix movies, and these titles by default have this title capitalization. So here we can modify this capitalization using the methods, but first we have to get access to the str attribute. So here we have to write .str, and now let's say that we want to make these letters into lowercase. So we have to use the lower method. So we write .lower, and with this we change the case of the text to lowercase. So I run this, and here we can see that now we have all the words in lowercase. So this is great, but now let's say that we want that case of text in uppercase. So we have to write this again. So I paste this one, and now instead of lower, we write upper. So with this, we make these words inside the title column into uppercase. So I run this one now, and here we can see that all the words now of these movies are in uppercase. And finally, the last case of text is the title case. So I'm going to show you here. So instead of upper, we write title. And here we got the same title we got before in the original data frame. And here is that title case. So now let's say we want to update the data frame with text in uppercase. So here I uncomment this, and now I paste it here. And here I only overwrite the values inside the title column. So here I write this, and now we run this one, and we'll see the data frame here. I'm gonna print it. So here df_movie, and now I run this. Here we get this warning, but it's fine. Nothing wrong happened, just a warning. And here we see that the title column has words in uppercase. So all of them now are in uppercase. But this looks a bit weird because all the letters here in the other columns are in title case, but this is the only column in uppercase. So I'm going to change it now to title case, but I'm going to use a different method. And in this case, I'm going to use the apply method. So here, instead of getting access to the str attribute, I'm going to use the apply with the lambda function and then use the title method. So here I'm going to show you. So I write df_movie, then the title column, and now I write .apply. So this is the apply method, and we've seen this method a lot in this course. So now I write lambda. So I'm going to create a lambda function, and here's the input, random variable. So I name it x, now colon, and now the output. And now I want to convert this x variable into title case. So I write x.title. And as you might remember, this x represents an element of this title column inside the df_movie. And that's why we use the title method without getting access to the str attribute. And before we run this code, I'm going to print this df_movie below this line of code. And now I comment this out, and here let's update the values inside this title column. So here I'm gonna overwrite the values. So I write this equal to the same column, but now with the apply method. So now I update and run this one. We get the warning message again, but everything is fine. And here in the data frame, we have the words with title case. And this means that the first letter in every word is going to be in uppercase, and the rest is going to be in lowercase. And that's it. In this video, we learned how to deal with inconsistent capitalization using the lower, upper, and title methods. Alright, in this video, we're going to learn how to remove blank spaces using the strip, lstrip, and rstrip methods. First, I'm going to show you how the strip method works. So here, I'm going to create a variable named movie_title. And here, I'm going to assign this to a value named Titanic. So here, I write Titanic, and I'm going to add these blank spaces at the beginning and at the end of this word. And I'm going to do this on purpose for the sake of this video. Here, we have these blank spaces, and here another blank space. So here I'm going to show you how the lstrip works, and here I write movie_title, and now I write .lstrip, and what this is going to do is it's going to remove the blank spaces at the beginning of this string. So now I print this, and here we can see that we don't have this blank space at the beginning of this text anymore, but we remove this blank space. And now let's try with the rstrip method. So what this is going to do is to remove the blank spaces at the end of this string. So here I print it, and now we can see that the last blank spaces are not anymore in this string. And now if we want to remove the leading and trailing spaces, we have to use the strip method. So instead of only removing the blank spaces at the beginning with the lstrip or the blank spaces at the end with the rstrip, now we're going to remove both with the strip method. So here I copy and now I paste this one, and here I delete the R, and now I'm going to apply the strip method. So here I run, and now we see that we only have the Titanic text and we don't have any blank space. And that's how you remove blank spaces with the strip method. And this is a really useful technique because sometimes when you have a data set, you don't know if the data set has some blank spaces in a column. And if you don't remove the blank spaces, you could get some unexpected behavior. And that's why it's always recommended to remove blank spaces from the text you're working with. And this is what we're gonna do with the title column here in our data frame df_movie. Now I write the name of the column, so title. Now I print this, and in the result that we got, it's not so obvious that we have blank spaces, but this column could have blank spaces. So we have to use the strip method in case this column has blank spaces. So here now I write .str because we need to get access to the str attribute before we use the strip method, and only now we can use the strip method. So we write .strip and parentheses. So with this we can remove leading and trailing spaces from this column. So now I run this, and here we got this column, but now without blank spaces. And here, to update the changes we made, we override the title column. So now I reassign it to this title column, and now I'm gonna show the data frame. So df_movie, I get this warning message, but it's fine. And here we see that the title column doesn't have any blank spaces. Great. Now I'm going to show you a different way to get rid of leading and trailing spaces, but now using the apply method. So here I'm going to write df_movie and select this title column. But now I'm going to use the apply method. So here .apply, and here inside parentheses I use the lambda function. So here lambda, then the input, then colon, and then the method I want to apply. So I write x.strip with parentheses. And here this x variable is an element from this title column, and that's why we can use the strip method without getting access to the str attribute. So now I comment this out and I run this, and we got the same result. And that's it. In this video, we learned how to remove blank spaces with the strip, lstrip, and rstrip methods. Okay, in this video, we're going to learn how to replace strings using the replace and sub methods. And as a first example, we're going to remove punctuation signs using the replace method and also regular expressions. But first, I'm going to show you the column we're going to work with, which is the title column. So here I write title. Now I run this, and here we have this data. So some of the movie titles that are listed here have some punctuations. For example, this second movie has the colon sign, and this is a punctuation sign. And sometimes when we work with text data, it's not a good idea to have numbers or some punctuation signs. And sometimes it's recommended to remove everything but letters. So that's what we're gonna do. We're gonna remove punctuation signs, and here I'm gonna use a regular expression to do that, and I'm gonna use it with the replace method. But first, I'm gonna show you the regular expression we're gonna use for this example. So we have to create a regular expression that matches punctuation signs. So here first, I'm gonna show you some popular symbols in regular expressions. And here I have two of the most popular symbols in regular expression. So the first one, /W, represents letters from the alphabet, so A to Z, also digits from 0 to 9, and also this underscore symbol. And the second symbol, /S, represents white spaces. And with these two symbols, I'm going to create a regular expression that matches punctuation signs. So to do that, first I write the /W. So with this, we get these elements. And now I write the /S. And with this, we get white spaces and letters from A to Z and digits from 0 to 9, and also the underscore. And something you need to know is that all the symbols that don't fall in these two categories are considered punctuation signs. So here we can use a not operator to get the opposite of these two symbols, and as a result get punctuation signs. And in regular expressions, the not operator is represented with the square brackets and the caret symbol in the beginning of this square bracket. So here I'm going to show you much better with the code cell. So I type Y, and here we have the code cell, and now you can see much better this symbol. So here in regular expressions we get the not operator by writing this caret at the beginning of square brackets, and this means match anything that is not letters or digits or underscore, and also not white space. So the remaining is only punctuation signs. So this is the regular expression we're going to use here in the replace method. So now that we have the regular expression, I'm going to use the replace method. So here I write that, and we need this str attribute to get access to the string that is inside this title column. And now I can write that replace, open parentheses, and as first argument we have to write the text we want to replace. So in this case we will have to write this regular expression. So I write quotes, and now this regular expression. So this means that we want to replace anything that matches with this regular expression. Then as a second argument we have to write the text we want to insert instead of this first argument. So here in this case we want to remove punctuation signs, so I only write quotes and nothing inside. And as a final argument I have to write this regex parameter and now set it equal to true. So this means that we are using regular expressions in our first argument. If we write regex equal to false, here the first parameter will be considered as a standard string and not a regular expression. So now let's try this out. I'm going to run this code, but first I want you to remember this second movie because this one has punctuation, which is this colon. So after running this line of code, we shouldn't get this colon in this second title. So let's try this out. I run this, and now we see the results. And here in this second movie, we don't see the colon sign anymore. So we successfully remove punctuation signs using this regular expression with the replace method. Okay, now I want to show you how to do this, but only with the replace method. So this one looks similar to what we built right now, but now we don't need the str attribute. So I can delete it, and we can use only the replace method. And the replace method works in a different way than the str.replace, because this second replace method can replace not only strings but also other data type like integers. However, this str.replace method only can replace strings because this str attribute limits the capabilities of this replace method. So we only can replace strings with the str replace method. And that's the big difference between these two methods. So now to show you this much better, I'm gonna use the title column again. And now I'm gonna try to replace numbers with the two methods. So first with the replace. So write replace, now 1, 2, and here regex equal to false because this is not a regular expression. And now I do the same but with the str.replace. So here I write str.replace. So now let's see how it works with the first line of code. But first I comment this out. And now let's see how it works with the replace method. So I run, and as you can see here, it replaces all the 1 numbers with this 2 number. And now let's try with the second method. Let's see if it works with the str.replace. So now I run, and as you can see here, I get an error. And here it says that it must be a string. So this str.replace only accepts strings in the first argument. And that's one of the advantages of the replace method over the str.replace. Okay, now I'm going to show you an alternative of the replace method, and in this case we're going to use the sub function, and this sub function belongs to the RE module. And this is the regular expression module. So first let's import it. So I write import RE. After that, we can use this function, but first we select the title column. So I copy and paste it here. And now we use the apply method. So apply, then parentheses, now the lambda function, the input x, and now the output here will be the re.sub. So this is the function, and now I open parentheses, and the first argument is going to be the same regular expression here. So I copy and paste it. Now the second is the element we want to insert instead of this regular expression. And here I write these empty quotes to remove this punctuation. And as a third argument, I have to write the variable I want to evaluate. So in this case, this x that I had it as input. And now this is ready. So I'm gonna comment this out so I don't have this anymore. So I comment this out and also this too. Now I run this and let's see the results. So here we see that this second movie doesn't have the colon sign, and with this we verified that we successfully removed all the punctuation signs in this column. And that's it. In this video we learned how to replace strings using the replace method and the sub function. In this video, we're going to see the dataset we're going to use in this section. So in this section, we're going to use a dataset that contains Boston house prices. And we're going to use this dataset to predict the values of the houses in Boston. So let's start by importing pandas as PD, and then let's read the CSV file. So pd.read_CSV, and then the name of the file is Boston house prices.csv. So now I run this, and here we got a data frame that contains 3 columns. The first column is the rooms column. This one contains the number of rooms that the house has. So usually if the house has more rooms, the price of the house will be more expensive. And if the house has less rooms, the price of the house will be less expensive. Then we have the distance column. This one contains the weighted distance to 5 Boston employment centers. And in this case, houses that are closer to employment centers will be more expensive. And finally, we have the value column. This one contains the median value of the owner-occupied homes in thousands of dollars. So what we're gonna do later is to predict the price of the houses in Boston. So we're gonna predict the value column. And to predict this, we're gonna use 2 columns as inputs. So we're gonna use the rooms column and also the distance column. Okay, now let's name this data frame. So now I write equal to, and now df_Boston. So this is the name of the data frame, and now I run this, and this is my new data frame. So now I show it again, and now let's see some statistical values of this data frame. So now I'm going to use the describe method. So I write describe with parentheses, and now we can see the number of rows this data frame has, also the mean and the minimum and maximum value. So for example, in the rooms, we can see that the mean number of rooms in these houses is 6. Also, the minimum number of rooms is 3 and the maximum is 8. So now is your time to familiarize with this data frame so you can understand much better the following lessons. In this video, we'll see one of the most basic machine learning algorithms. This is the linear regression. The linear regression is an approach for modeling the relationship between 2 or more variables. When we have only 2 variables, we're dealing with a simple linear regression. But when we have more variables, we're dealing with a multiple linear regression. In a simple linear regression, one variable is considered the predictor, also known as the independent variable, while the other variable is known as the outcome, also known as the dependent variable. This is the linear regression equation. Here, y is the dependent variable, also known as the target value, and x1, x2 until xn is the independent variable. Here also b0 is the intercept, while b1, b2 until bn are the coefficients, and n is the number of observations. This equation is represented by this graph. So in this graph, we can see a linear relationship. So if one independent variable increases or decreases, the dependent variable will also increase or decrease. Linear regression can be used to make simple predictions, such as predicting exam scores based on the number of hours studied, also the salary of an employee based on years of experience, and so on. Okay, as I mentioned before, the equation behind this graph is this one that now you see. So the first one is the general equation or the complete equation, and the second one is the simplified equation. This one represents a simple linear regression because we only have one dependent variable and one independent variable. Some people use this notation, but some others use y equal to a multiplied by x plus b. So these are two popular notations, and you have to keep in mind that people use both. Okay, now let's see what are the dependent and independent variables of our dataset that we've seen in the previous video. So in the previous video, we read a Boston house prices CSV file, and this CSV file had 3 columns. This dataset has information about the number of rooms, also the weighted distance to 5 Boston employment centers, and also the value of a house. So here first, we're going to see the simple linear regression, and in a simple linear regression, we have one predictor and one target. And in this case, our predictor is going to be the number of rooms, and our target value or target variable is going to be the value of a house. So we're going to predict the value of a house based on the number of rooms. So we can say that the number of rooms is the independent variable and the value of a house is the dependent variable. So this is for our simple linear regression. But now for the multiple linear regression, we're going to have 2 independent variables. So the number of rooms and also the distance. And the target variable is going to be the same. So the value of a house. So for this multiple linear regression, we have 2 predictors and 1 target. Alright, that's it for this video. And in the following videos, we'll implement all of this using Python. Okay, in this video, we're going to implement linear regression in Python. And there are 2 ways to implement linear regression in Python. And 2 simple ways to implement linear regression in Python is using the stats model and the scikit-learn libraries. Both are popular libraries used in machine learning, and we're going to learn how to do it with both. And in this video, we're going to use stats models. So to use stats models, we have to import this writing the following. So we write import stats.model, and then we write .api, then as, and here we write sm. So this sm represents this stats models.api. So now I press Ctrl Enter to import this stats models library, and now we imported this. And stats models is a module that helps us conduct a statistical tests and estimate models. And some of the benefits of stats models over scikit-learn is that it provides an extensive list of results for each estimator. And now before we create this linear regression, we have to read the dataset we've seen before. So these Boston house prices. So now I run these 2 cells, and here we have the dataset. So now let's create this linear regression. So we'll start with a simple linear regression. And the first thing we have to do is to define a dependent and independent variable. This is the first step you have to do always when you want to create a simple linear regression. In the previous videos, we discussed what are the dependent and independent variables. So the dependent variable is the value we want to predict, and it's also known as the target value. On the other hand, the independent variable is the predictor. In our dataset, so this df_Boston data frame, we have two predictors. So we can use any of them in our simple linear regression. In this case, I'll choose the rooms column as the independent variable. And the dependent variable is going to be the value column. So now let's define the dependent and independent variable, but now in Python. So here, I'm going to write df_Boston, and then I'm going to select this column, the value column. So this is my dependent variable, and now I'm selecting this column. So now I set this equal to y, and y is my dependent variable. So now I'm going to do the same, but now with the independent variable. So now my independent variable is going to be named x, and I'm going to select the rooms column. So with this, we have the dependent and independent variables. Okay, and before we create our simple linear regression, let's explore our dataset. A common way to explore a dataset is using scatter plots. So a scatter plot allows us to see how the data is distributed. So to make this scatter plot, I'm going to use the plot method that comes with pandas. So I'm going to write df_Boston.plot, and now I write the kind parameter equal to scatter. Then I add the x and also the y parameter. So now x and y. And now I'm gonna set the x equal to these rooms and the y equal to value. So with this, we can plot this data frame, and now I press Ctrl Enter, and here we have our scatter plot. So in the x-axis we have the rooms, and in the y-axis we have the value. And we see that most of the data is located here in the middle. So what we're gonna do in the next step is to create a simple linear regression that fits best these data points. So the line that fits best these data points is the one we're gonna choose. So let's create this line and let's write the code here. And here, to make a regression, we have to add a constant and fit the model. First, we need to add a constant because stats model by default doesn't add the constant that we have in the equation of the simple linear regression. So if you remember, there was a b0 that represented the constant, and by default stats model doesn't add this constant, but we can add it manually. So here I'm going to write the code that helps me add this constant. So I write sm, then I use the add_constant method. So with this, we can add a constant. So now I have to write the independent variable, in this case the number of rooms, which is x, and with this we add a constant. So now I'm gonna write x equal to this, and this x represents the independent variable, but now with a constant. So now that we added the constant, we can fit the model. So to fit the model, we only have to use the OLS method. So I write sm.ols and then parentheses. And here, first we have to write the dependent variable, which is y, and then the independent variable, which is x. Then to fit this model, we use the fit method. So I write fit, then parentheses, and with this, we fit our model. And by the way, fitting the model means finding the optimal values in the equation of the linear regression. So we obtain a line that best fits the data points. A model that is well fitted produces more accurate outcomes. So only after fitting the model, we can predict the target values using the predictors. Okay, before I predict the values, I'm gonna name this. So I'm gonna name it LM, which stands for linear model. So I run this, and here I got an error because I didn't run the previous cell. So this one, in which we define the dependent and independent variable, I didn't run this cell. So now I press Ctrl Enter, and with this, I define the dependent and independent variables. So now I can run this cell too, and now we added the constant and fitted the model. So now we can predict the values of these houses. So I'm going to use the LM, which is the linear model we created, and now I use the predict method. So I write predict, and now I introduce the independent variable, which is x. So this X represents the number of rooms. So with this X, we're gonna predict the values. And here we got the values of the houses. So we predicted these values based on the number of rooms. Okay, now let's see how this linear model performs. And to do that, we're gonna use the regression table. This table provides an extensive list of results that reveal how good or bad is our model. So to get this table, we only have to use the summary method. So we write lm.summary and then parentheses. With this, we get this table. And this table has 2 or 3 parts. So the first one is the OLS regression results. And OLS, it stands for ordinary least squares. And this is the most common method to estimate linear regression. Then in the second and third tables, we'll see more values. So now let's see which are the most important values in these tables. So let's start with this depth variable, which means dependent variable. So we can see that our dependent variable is the value. So this is the value of the houses. Then we have the R squared, and this R squared takes values from 0 to 1. The R squared values close to 0 corresponds to a regression that explains none of the variability of the data, while values close to 1 correspond to a regression that explains the entire variability of the data. So the R squared we got here is telling us that the number of rooms explains 48.4% of the variability in house values. Then we have the coef column. And here we can see the coefficients of the linear regression equation. So the first one is the constant, and the second one is the coefficient that corresponds to the rooms variable. Then we have the standard error column, and this one represents the accuracy of the prediction. The lower the standard error, the better prediction. Finally, these t-scores and p-values are used for hypothesis test. Okay, now let's use these coefficients to create the line that best fits the data points that we've seen before in the scatter plot. I already have the coefficients, so 9 for the rooms variable and -34 for the constant. So here the linear equation is a times x plus b, and we're gonna replace the values of the coefficients a and b in this equation. So now I create a y underscore pred, and this is equal to 9.1021 multiplied by the x variable, which is the number of rooms. So this one is x and here rooms. So I'm selecting the rooms column, and now plus b, and in this case b is -34, so I only write this -34. And with this we have this equation that corresponds to the line that best fits the data points we've seen before. And now let's plot this line. And to plot this line, I'm going to use advanced data visualization libraries such as Seaborn and Matplotlib. So here I have the code to plot this line with the scatter plot, and I'm using in this case Seaborn and Matplotlib because these two libraries allow me to put the scatter plot and the line plot in one graph. So you don't have to memorize this code. The most important part is this line, and here we indicate that we want to make the line plot, and as a y parameter we write the y underscore predict, and here this is the equation we created before here, and also in the x parameter we set it this equal to the rooms column in the data frame, and that's everything you need to know. So now I run this and we're gonna see the scatter plot, but now we also see the line plot, which is in red. So we can say that this red line is the line that best fits the blue data points. By the way, you don't need to create this plot. I just made it to show you how this regression line looks. And that's it for this video. In the following video, we'll see how to make a multiple linear regression with Python. Alright, in this video, we're gonna see how to create a multiple linear regression with stats models. So first we have to read the same data frame, df_Boston. And now we have to import stats model. So we write import stats models.api as SM. So with this, we can start this. And here I just need to add the S. And with this, I imported stats models. And now let's define the dependent and independent variable. So in this case, it's going to be independent variables because we're going to have more than one variable. So I'm going to show you here. And the df underscore Boston is this one. And here we have the dependent variable, which is the value column. And the independent variable is going to be, in this case, the rooms and the distance columns. So now let's define this using pandas. So the dependent variable is df square brackets, and here I write value. So I'm going to set this equal to y, and with this we have the dependent variable. So now I can copy this one, and here I forgot to write underscore Boston. Okay, so now I copy this one, and with this we can create also the independent variable. So I write here x, and here instead of value I'm going to write rooms and distance. But here we have to write double square brackets because we want to select two columns. So here I write rooms and distance. So I copy, and now I paste it right here. So now I write comma and add the quotes. So with this we have the dependent and independent variables. So I run this, and now it's time to make the regression. So let's add a constant and fit the model. So first, to add a constant, we have to follow the same steps we did in the simple linear regression. So we write sm.add underscore constant, and then inside parentheses we have to write the independent variable. So in this case is x, and now we set x equal to this. So with this we're gonna get the independent variables, but now with the constant. So here I'm gonna fit the model, and to fit the model we used OLS. So I write sm.ols, and here first we have to write the dependent variable, which is y, and then the independent variable, which is x. Then we fit the model using the fit method, and I'm going to set this equal to LM, which stands for linear model. So with this we run, and we created our multiple linear regression. So now we can see how this model performs by using the summary method. So we only have to write lm.summary, then parentheses, and we get the same table we got in the simple linear regression. So the table is similar, but in this second table you're gonna see that there is an extra row, and this extra row corresponds to the independent variable that we added. So before we only had the rooms variable, but now we have also the distance variable. Here also we can see that the r squared increased a little bit, and overall the analysis of this table that we got after creating the multiple linear regression is similar to the one we obtained after creating the simple linear regression. And that's it for this video. In this video, we learn how to implement the multiple linear regression in Python. Alright, in this video, we're gonna see how to create a linear regression using sklearn. sklearn, also known as scikit-learn, is the standard machine learning library in Python, and it can also help us make either a simple linear regression or a multiple linear regression. In this case, we're going to see how to make a multiple linear regression with sklearn, but the steps to make a simple linear regression are going to be the same. So now let's start by importing linear model from sklearn. So we write from sklearn import linear model, and this linear underscore model has everything we need to create our linear regression. So now I run this, and after we imported this, we have to define the dependent and independent variables. So now this is going to be exactly the same as we did previously with stats model. So I'm going to write it again. So first, the dependent variable is df underscore Boston, and here I'm going to select the value, which is the target. And now I copy and paste it. So I create the independent variables, And here I'm gonna write x equal to, and here I'm gonna select 2 columns. So I write double square brackets to select 2 or more columns. And now I copy and paste these rooms and distance. So with this, we create that independent variable. So after we do this, we're gonna fit the model. So now to fit the model, we only have to use the fit method. And by the way, here with scikit-learn, we don't need to add a constant as we did with the stats models library, because scikit-learn adds this constant by default. So we only have to fit the model. So now I write linear underscore model, which comes from this one that we imported before. And now I use the linear regression method. So I write linear regression, now parentheses, and now I set it equal to LM, which stands for linear model. So now to fit the model, I use the fit method, and here I write x, comma, y. So keep in mind that here the order is different from stats models, because in stats models, first you write y and then you write x. But in scikit-learn, first we have to write the independent variable and then the dependent variable. So keep that in mind. Okay, now let's run this cell, and with this we fit the model. So now let's predict the values. So we write again lm, and we use the predict method. So dot predict, and inside parentheses I write the independent variable, which is x. So now I run, and with this we predict the values of the houses using the independent variables. So here we got an array, and this represents all the predicted values. And now if you want to select only the first 5 predicted values, you only have to write square brackets and then write column 5. And with this we select only the first 5 values in this array. Then if we want to get the values in the summary table that we got using stats models, we have to use individual methods, because with scikit-learn there is not a single method that can help us get the same summary table that we obtain with the stats model library. So in this case, for example, if we want to get the r square score, we have to use the score method. So I only have to write lm.score and then write x, comma, y. So the independent and then the dependent variable. So now I run this, and with this we got the r square, which is the same value to the one we got with stats models. Then we can also get the coefficients. We only have to write lm.coef underscore and run this, and we got the same coefficients we got with stats models. And we can also get the intercept by using the intercept underscore attribute. So we only write lm.intercept and underscore. So now I run, and we can see now that the intercept is minus 34, which is the same value we got in the summary table using stats models. In this case, I'm not going to explain the meaning of these values because they are the same values we got before, so the analysis is the same. And if you want, you can compare the values to verify that we got the same result. In the following videos, we're going to use the scikit-learn library because it's the standard machine learning library used in Python, and it's more powerful than stats models. Alright, in this video, we're going to see the dataset we're going to work with in this section. So first, let's import pandas, and then let's read this dataset. So import pandas as PD, and then we use the read underscore CSV method to read this CSV file. So read underscore CSV, then the name is IMDb dataset. So here, dataset.csv. So this is the name of our data frame. Now we read. Okay, the dataset that we have now is an IMDb dataset that contains 50,000 movie reviews, and this dataset contains 2 columns. The first column is the review column, and in this review column you will find what the users think about a movie. So that's what they think, if that movie was good for them or terrible. So based on that review, we will get a positive or negative sentiment. And you will find that data in the sentiment column. So the sentiment column contains the sentiment of the review. So if it's a good review, you will have a positive sentiment. So if the review has words like great, awesome, good movie, the sentiment will be positive. But if the review has words like bad, terrible, the sentiment will be negative. So our sentiment column only have positive and negative values. I chose this dataset to create a basic machine learning model. So the model that we're going to create will predict whether a review is positive or negative. And we're going to use this dataset as input to feed our model. But first, we need to transform this data frame in order to build the model. So we're going to try different machine learning models in this section. And our final goal is to find which machine learning model is best suited to predict sentiment given a movie review. So the sentiment is going to be the output of our model, and the movie review is going to be the input of our model. Remember that because that's the foundation of this project. So the sentiment is going to be the output and the movie review is going to be the input. All right, as you can see, this data frame has 50,000 rows. However, to train our model faster, we're going to take a smaller sample of 10,000 rows. This small sample will contain 9,000 positive and 1,000 negative reviews to make the dataset imbalanced. So I can teach you undersampling and oversampling techniques in the following videos. All right, we're going to create this small sample with this code here. So here below, we're going to write the code that will allow me to take a sample of 10,000 rows to make processing faster and get imbalanced data. All right, before we create this small sample, let's give a name to this data frame. So now I'm going to set this data frame equal to df underscore reviews. So I write df underscore reviews, and then I run this code. So here I run, and now we have our data frame. So now let's take a sample of 10,000 rows to make processing faster and also get imbalanced data. So now I write df underscore reviews, and then I'm gonna make a condition. So I select only the data I want. So here I write sentiment because that's the column we want. So I'm gonna show you here again the data frame. I'm gonna select the column sentiment, which is this one. And now we write double equal sign to select only the positive sentiment. So positive. And now I'm going to select this by writing the name of the data frame and then putting this inside square brackets. So this is the selection we make, and we learned this in the previous videos, how to filter a data set. And now I'm going to run this and let's see the output. So here we have the data frame, and we see that all the data inside the sentiment column is positive. So we only have positive sentiment. So now we have here 25,000 rows, but as I mentioned before, we only want 9,000 rows that correspond to the positive sentiment. So here I'm going to select only 9,000. So I write colon and then 9,000. And with this, we're going to get only the first 9,000 positive sentiment. All right, now let's do the same, but now with the negative sentiment. So now I write negative, and now I select only the first 1,000 rows. All right, with this, we have 9,000 positive reviews and 1,000 negative reviews. So now let's give a name to these two data frames. So here I'm going to name it df underscore positive. And the other is going to be df underscore negative. So now df underscore negative. And here we have our two data frames. So here we have 9,000 df underscore positive and 1,000 negative. So now I write it here And now let's run this code. So to create our two data frames. So now we have our two data frames. Now let's concatenate these two data frames so we get only a single data frame as we had before here in this df_reviews. So here, let's concatenate vertically. So I write pd.concat, then parentheses. Now I open these square brackets, and now I write the name of the two data frames we created. So first df_positive and then df_negative. So these are my two data frames. And now let's run this, and here we concatenated these two data frames vertically. So now we have this data frame, and this data frame contains positive and negative reviews, and 9,000 positive and 1,000 negative reviews. So now let's give a name to this data frame. I'm going to name it df_reviews_imb. This imb stands for imbalanced. And we can say that we have imbalanced data when we have a large amount of data for one class and much fewer observations for other class. So this is known as imbalanced data because the number of observations per class is not equally distributed. So here we have 9,000 positive reviews and we have 1,000 negative reviews. So 9,000 is way bigger than 1,000. So we can say that we have imbalanced data because the sentiment of the review is not equally distributed. Okay, now this df_reviews_imb represents our imbalanced data. So now I run this, and now let's see how this data frame looks. So now I paste this, and this is the data frame we got after concatenating the positive and negative reviews. Now let's see how it's distributed. So now I use the value counts method. So I write value_counts, and now we write the name of the sentiment column. So here I open quotes and write sentiment. So now I run this, and here we have that there are 9,000 positive and 1,000 negative reviews. So we verified that this data is indeed imbalanced. And in the following videos, we're going to see how to deal with imbalanced data. And that's it for this video. In this video, we had a look at the IMDb dataset, and also we selected only a few positive and few negative reviews. So we made that data imbalanced, and we created this df_reviews_imb data frame. In the next video, we're going to see how to deal with imbalanced data. In this video, we're going to see the undersampling and oversampling techniques. Oversampling and undersampling in data analysis are techniques used to adjust the class distribution of a dataset. Both techniques helps us deal with imbalanced data. In some cases, we should avoid imbalanced classification because it can influence the performance on our machine learning algorithms. That said, both oversampling and undersampling involve introducing a bias to select more samples from one class than from another to compensate for an imbalance that is either already present in the data or likely to develop if a purely random sample were taken. Okay, let's see how both undersampling and oversampling work. Okay, first let's see undersampling. And undersampling is just deleting samples from the majority class. So here we have two classes, the blue class and the yellow class. So the blue class is the minority class, and the yellow class is the majority class. Okay, now let's imagine that we have movie reviews and the minority is represented by the negative reviews and the majority is represented by the positive reviews. So if we want to balance that dataset, we have to undersample the majority class. That is, deleting samples from the majority class. So in this case, we will delete samples from the positive reviews. So from the majority class. We do this because we want the same number of observations in both categories. So we want the same number of positive and negative reviews. So we reduce the number of positive reviews, so we get the same number of reviews. Okay, now let's see the oversampling. And oversampling is just duplicating samples from the minority class. So here again, the majority class is the positive reviews and the minority class is the negative reviews. So now if we want to balance this data by oversampling, we need to increase the number of observations of the minority class. So we have to duplicate some samples in this minority class, and we do this, and in the end we'll have the same number of observations between the minority class and the majority class. So this means that we will have the same number of positive and negative reviews. So now you might be wondering which one is better, oversampling or undersampling. So the answer depends a lot on the data that you're working with, and also depends a lot on your project's goal. So sometimes it'll be better to oversample your data, but in some other cases, it'll be much better to undersample your data. All right, now let's implement the oversampling and undersampling techniques to our project. So let's go to Jupyter Notebook, and here we're going to start by making a bar plot to show how the data is distributed. So now I'm gonna write the name of the data frame that we created before, which was df_reviews_imb. So this imb stands for imbalance, and this is our imbalance data. And we're gonna use the plot method to plot this data frame. And now I'm gonna use the kind parameter and set it equal to bar. Then I'm gonna use the value counts method to only get the number of elements the sentiment column has. So here I copy sentiment, and now I write value underscore counts, then parentheses, and now I write sentiment. So I'm gonna plot this output, and now this is ready. So I press Control Enter, and now we have this bar plot. And this bar plot is useful to show how the data is distributed. For this particular example, it might look a bit unnecessary, but when you have many categories, this becomes really useful. Okay, in this plot, we can see that the majority class is the positive reviews because we have 9,000 reviews. And the minority class is the negative reviews because we only have 1,000. So here we have two options. We can undersample the positive reviews, or we can oversample the negative reviews. For this example, I'm gonna undersample the positive reviews, and now I'm gonna show you two different ways to undersample a class. So now let's scroll down, and here let's undersample the positive reviews with the sample method. And to do this, first we have to calculate the length of the negative reviews. And to do that, first we write df_reviews_imb. Then we select only the negative reviews. So here I write sentiment, then equal to negative. And now we filter this with these square brackets. So now we only have negative reviews. And now to calculate the length of these negative reviews, we use the length function. So now I'm gonna set this equal to length underscore negative. And with this, we can see the length of these negative reviews. So here I'm gonna print it, and is 1,000. Okay, now we're gonna extract a sample from these positive reviews, and this sample is gonna be equal to the length underscore negative. So we get in the end the same number of observations. So I write first df_reviews_imb, and now I'm gonna select only positive reviews. So now I write sentiment again, then equal to, and here positive. Now I filter this with square brackets, and here I'm gonna use the sample method. So I write that sample, and inside parentheses, I write the n parameter and set it equal to length underscore negative. So with this, we're going to extract only a sample of 1000 from these positive reviews. So now let's try this out, and here I have the output, and we see that in the sentiment column there are only positive reviews, and here we see that we have only 1000 rows. So we got 1000 positive reviews. So this is the output we wanted. So here I'm going to set this equal to df underscore reviews underscore positive. So this is my new data frame. Okay, now let's extract only the negative reviews, and then we're gonna concatenate the positive and negative reviews. So I'm gonna use this code because this code already gets the negative reviews. So is this one, I run, and as you can see, we have in the sentiment column only negative reviews, and we have 1000 rows. So I'm gonna set this equal to df underscore reviews underscore negative. So now I run and I created this data frame. Now let's concatenate these two data frames, the positive and the negative. Okay, now I write pd.concat, then open parentheses, and then open square brackets. Then I write the name of this positive data frame, and then comma, and then I add the second data frame, so the negative reviews data frame. So now we concatenate these two data frames and let's run. So here we have a data frame with positive and negative reviews. And we see that now we have 2000 rows. And if we check the distribution of this sentiment column, we will see that now the data is equally distributed. So now we have 1000 negative reviews and 1000 positive reviews. So this is what we wanted. Now the data is balanced. So now I'm going to set a name to this data frame, and the name is going to be df underscore reviews underscore val, and this val stands for balance. So now I run this and we created this data frame. So now let's check again, because I think the indexes are not properly assigned. So here first I'm gonna delete this value underscore count so we get the concatenation. So now I run again, and now I run this df underscore reviews underscore val, and now here we see that the indexes are not sorted ascending. So let's reset the index. So it starts with 0 and then 1, 2, 3 and so on. So now I write reset underscore index, and here in the parentheses I write drop equal to true, and then I add the in place parameter and set it equal to true to update this data frame. So now I run this, and here we have the result. So now I'm going to print this data frame and see the index. And now we see that the index starts now with 0. And as you might remember, if we use the value counts, we can verify again that the sentiment is equally distributed. So now we have 1000 positive and 1000 negatives. So this is the first way to balance data using the sample method. And now I'm going to show you an easier way to balance data. And the second way to balance data is using the random undersampler. And to use this random undersampler, first we need to install the imb-learn library. And to install this library, we have to write exclamation mark and then pip install imb-learn. So now we run this and wait a couple of seconds until the installation is done. So now the installation is finished, and now we can import the library. So I'm going to delete this. And now to import the random undersampler, we have to write the following: from imb-learn dot underscore sampling import random undersampler. So here I'm gonna just copy and paste this to write it faster. So here is import random undersampler. So now I run this, and now we successfully imported this random undersampler. So now to undersample the positive reviews, first we have to create an instance of this random undersampler class. So here I write rus equal to random undersampler, and here in parentheses, I write the random state. This is just a way to control the randomness of the random undersampler, but it's not necessary. But here I set it equal to 0, so I write equal to 0, and now we create this RUS that stands for random undersampler. Okay, now to resample the imbalanced data df_review_imb, we have to feed the RUS variable that we created here, and we have to use the feed_resample method. So here the X represents the data which have to be sampled, and the Y corresponds the labels for each sample in X. In this case, X is the review column and Y is the sentiment column. So now let's resample the imbalanced data. So here, instead of X, I'm going to write df_review_imb. This is the dataset that is imbalanced. And now I'm going to select only the review column. So now I add double square brackets, and now here I select the review column. And here in the Y argument, I write the sentiment column. So here I copy the name of the data frame, and now I select only the sentiment column. So sentiment. And now keep in mind that the first argument should be a data frame, while the second argument should be a series. So this is a 2D and this is a 1D. This is how the feed_resample works. And you can also see that I used here double square brackets for the data frame, because if I use double square brackets, I get a data frame as output, but if I use only a single pair of square brackets, I get a series as output. So keep that in mind. So now I'm going to run this and let's see the result. And here I got an error because I didn't write the name of the data frame correctly. So I add the S, and now here the S2, and now I ran. And this is the output of the last line of code that we wrote. So this is the review column and this is the negative column. So now let's assign this to a new data frame. And this data frame is going to be the balanced data frame. So here I write df_review_val. And something I almost forget to tell you is that this output that we got after using the feed_resample method has two elements. So the output has two elements, and the first one is this data frame. So this is a data frame, and this data frame has only one column. And the second output is a series. So this one is a series. So here apparently is only one element, but actually we have here two elements. So this is the first one and this is the second one. And the first one is a data frame because here we introduce a data frame in our first argument. So it makes sense that we input a data frame and we output a data frame in the first element. And here in the second element, we insert a series. So again, we input a series and we output a series too. So this second element is a series. So now let's continue here. So first, this is my data frame and the name of the data frame is df_review_val. And this represents the first element, so the data frame, so this one. And now I'm going to write the series that corresponds to this second element, so the sentiment column. So now here I write df_review_val, but now I select only a column and it's going to be sentiment. Since this df_review_val data frame is new, what we're doing here is to create a new column for this data frame. So this column is going to be sentiment, and actually we're adding this column to the df_review_val that I'm creating right here. So now let's set all of this equal to the expression that we wrote here. And anyway, you can see here that we resample the reviews and also the sentiment. So now let's run this and see the result. So now I run this code and now let's see the data frame we just created. So here we have the df underscore review underscore val, and now we have this data frame. So here we have the review and the sentiment column, and we see that now we have only 2000 rows, and apparently we undersampled the data. But now let's verify if that's true. So let's use the value underscore count method to count the elements inside the sentiment column. So now I copy the name of the column, I open parentheses, and now I run this code. So now let's verify. And here we have 1000 negative reviews and also 1000 positive reviews. So we successfully undersampled the data using the random undersampler. By the way, in this example, I used the random undersampler because I chose to undersample the positive reviews, but in case you chose to oversample the negative reviews, you only have to use the random oversampler. And you can do this by importing the random oversampler from the imblearn.oversampling. And that's it. In this video, we learned the oversampling and undersampling techniques. Okay, in this video, we're gonna see how to split data into train and test. Before we build our model, we have to split the data into a train and test set. The train data set will be used to fit the model, while the test data set will be used to provide an unbiased evaluation of a final model fit on the training dataset. Remember that we always have to split our data into train and test set before building our model. Alright, now to split the data into train and test set, we're going to use the sklearn library. And this library comes with Anaconda, so we already have this library installed, so you don't have to install it. So let's use the sklearn library. So I write from sklearn, and then we write dot model underscore selection, and we import the train underscore test underscore split. So this train underscore test underscore split will help us split data into train and test. So now the only thing we have to do is to use this train test split, and now open parentheses. So after we do this, we have to introduce the name of our dataset. In this case is df underscore reviews underscore val. So this is the balance dataset that we created before. And now we have to split the data, and we have to set the size of the split. So here I write the test underscore size parameter and set it equal to 0.33. So this 0.33 indicates that we want to set the 30% of the data frame df underscore reviews underscore val to the test data, and the remaining 67% will be assigned to the train data. So now I'm going to assign this to train comma test. So this train underscore test underscore split will return two values, and these two values are the train and the test. So the 67% and the 33%. And before running this code, I'm gonna add an extra parameter that you don't need to add, but I'm just gonna do it to control the random state. So I add random underscore state, and this set it equal to 42. This helps me set the same random values no matter how many times we run this code. So with this, I control the randomness. So here, now I can run this. So now I press Control Enter, and here I got an error because I didn't write correctly the name of this model underscore select. Actually is model underscore selection. So I write selection, and now I run. And now we successfully created this train and test data frames. So now I'm going to show you the trained and the test data frame. So this is the trained data frame, and here we have approximately 67% of the data, and in the test data frame we have 33% of the data. And another good practice that we have to follow before building the model is to create an X and Y variables. So the X represent the independent variables and the Y represent the dependent variables. So for example, we should split the train into train underscore X and train underscore Y. So in the train underscore X, we should have only the predictors, also known as independent variables. And in the train underscore Y, we should have only the dependent variables, also known as the target label. In case you don't remember the definitions of independent and dependent variables, I'm going to make a recap. So the dependent variable is the value we want to predict and is also known as the target value. And the independent variable is the predictor. In our example, the dependent variable is the sentiment because this is the value we want to predict. And our independent variable is the review because this is our predictor. So with the review, we predict the sentiment. Okay, now let's set the independent and dependent variables within our train and test set. So here I'm going to write train and then I'm going to select only the review column. And then I copy this, I write comma and I write train, and here I'm going to select only the sentiment column. So the review is my predictor. So this is my independent variable. So here I set this equal to train underscore X. So X is the independent variable, also known as the predictor. And here the sentiment is the dependent variable. So I'm going to set this equal to train underscore Y. So the Y is the dependent variable. So X is independent and Y is the dependent variable. And I'm going to do the same for the test dataset. So instead of writing train, I'm going to write test. But here I'm going to show you a shortcut. So here if I press the key F, we're going to see this find and replace. And here I can write the word train. So it matches 4 words that have the word train. And now I can replace it for test. So if I write test here, we can replace the word train with the word test. So now I click in replace all, and now voila, we have test instead of train. So now I'm gonna copy and paste this one here again. And now I'm gonna run this code and we'll see the result. Okay, and as I mentioned before, the train dataset, so these two will be used to fit the model. So now let's see how these two datasets look. So first the train underscore X. So this one contains only the review column. And now the train underscore Y should contain the sentiment column. So yeah, we have this. And now let's count the number of positive and negative reviews. So I use value underscore count, now parentheses, and we got 675 positive reviews and 665 negative reviews. And that's it. In the following videos, we'll use this train underscore X and train underscore Y we just created. In this video, we're gonna learn what is bag of words. The bag of words model is a representation that turns text into fixed length vectors. This helps us represent text into numbers, so we can use it for machine learning models. The model doesn't care about the word order, but it's only concerned with the frequency of words in the text. The typical bag of word workflow involves cleaning raw text, tokenization, building a vocabulary, and generating vectors. We can do all of this in Python using a tool called Count Vectorizer that takes care of most of the bag of word workflow. And to understand how the Count Vectorizer works, let's see an example. And in this example, I have 2 reviews that show the opinion that people have on Python and on Java. So to implement the bag of words through the Count Vectorizer, we only have to count the number of times each word appears in both sentences. So we can build a table, and in this table could show the number of times each word appears in the sentences. So let's have a look. This is a table I built, and as you can see here, I have the sentence, the 2 sentences or 2 reviews, And also in the table, I have how many times each word appeared in each sentence or each review. So for example, the word could appeared 2 times in the first review. So in the first review here, we can see that the word could appears after the word writing and also after the word Python. So yeah, it appears twice in this first review. So this is how you build this table, and this table represents a document term matrix that we're going to see later, and we obtain this document term matrix by using the count vectorizer in Python. By the way, keep in mind that words with 2 letters or fewer are not taken into account by the count vectorizer. Alright, now let's see how to implement the count vectorizer in Python. So now we go to Jupyter Notebook, and here let's import the count vectorizer. So we write from sklearn dot feature underscore extraction dot text. So here dot text. Then import, and here we write count vectorizer. So I write count and then vectorizer. So now I'm gonna paste the text that we had before. Okay, I just pasted the text we had before, and now I'm gonna create a data frame. So I use the pd.data frame, and now I open parentheses, and now I create this data frame with a dictionary. So I open curly braces. Now I create the first column, which is gonna be review. So the first column is review, and then I create the elements. So the first element is going to be review 1, and the second element is going to be review 2. And now I create a second column, and it's going to be named text. So this is the name of my second column, and the value that is going to have is the text list that I have here. So this is my list, and now I just paste the variable. So now I'm going to create an instance of the count vectorizer. So here I copy and paste count vectorizer, then open parentheses, and that's how I create an instance of this count vectorizer. So I'm going to name it this CV. So CV, that stands for count vectorizer. Now we can add a parameter here. So I want to add the stop words parameter, and this one will help me filter out stop words. After this, I'm going to use this CV I created, and now I'm going to feed this count vectorizer. So I use the feed underscore transform, and inside parentheses, I have to write the name of the data that I want to feed to this count vectorizer. So in this case, I want to feed this text list. So I'm going to put the name of the text column. So I write df, then open square brackets, and then text. So this column has the data that I want to feed to this CV that is the count vectorizer. And by the way, the feed underscore transform method works in this way. First, the feed will find the best parameters that fit to this data, and then the transform will transform our data using these optimal parameters. Okay, so we can run this to see the results we have so far. So now I run, and as you can see, the result after feeding and transforming this data is only this sparse matrix that we cannot actually see. But now if I create another data frame, we can see this sparse matrix into this data frame. So I'm going to do this now, and I'm going to create this data frame, and I'm going to name it df underscore DTM. And this DTM stands for document term matrix. This is what we're going to build. So now I'm going to use here the pd.data frame again. So I just copy and paste this one because we're going to build a data frame. And now I open parentheses, and here the first argument we're going to introduce is the data. So the data that we want to show in this data frame is this sparse matrix. So I'm going to name this sparse matrix, and the name is going to be CV underscore matrix. So this is the name. Now I run, and now we add this sparse matrix to the first argument. So we show this sparse matrix in the data frame. Now the second argument is going to be the index, and this index is equal to df square brackets, and here the review. So here we're gonna get the review 1 and review 2 in the indexes. By the way, here I almost forget to add the to array, because here now this is a sparse matrix, but I want to get an array. So I use the to array, so I only get the values inside. And also here we want the values. Right now we have the series, so it's the review series, but I only want the values, so I use the values attribute, and with this we get only the values. Next, I'm gonna add the columns parameter and set it equal to cv.get_feature names. So this one. Now I open parentheses, and with this we're setting each word that appears in these two sentences in the column of this df_dtm data frame. So with this, our data frame is ready. So now I run this, and now I show you the results. So here, this is the result. So this is the same table we had in the slides, and we build it with Python. So in this case, it might seem unnecessary to make this little table, but now imagine that you have many sentences, or you have a movie script with a lot of text, and in that case you will need to use a tool like the count vectorizer to show the frequency of the 1,000 of words that movie has. And that's it for the count vectorizer. Now let's see another way to implement the bag of words in Python. So now we're gonna see the TF-IDF, and TF-IDF stands for term frequency inverse document frequency. So the first one, the term frequency, is the TF, and the last one is the IDF. Unlike the count vectorizer, the TF-IDF computes weights that represent how relevant is a word to a document in a collection of documents, also known as a corpus. The TF-IDF value increases proportionally to the number of times a word appears in the document, and is offset by the number of documents in the corpus that contain the word. The TF-IDF has applications in information retrieval, like search engines, that aim to deliver results that are most relevant to what you're searching for. So for example, Google, when you search a keyword, Google returns the most relevant information to you. So that's some kind of basic TF-IDF application there. Okay, before we see the Python implementation of this TF-IDF, let's see an example so you have a good idea of how the TF and IDF are calculated. The TF-IDF is calculated by multiplying the TF and the IDF. And now let's see how to calculate the TF. So the TF is the term frequency, and this one looks like the count vectorizer, because here we only count the number of times a word appears in a text. So as an example, let's take the same two sentences that we use in the count vectorizer. So here we have similar output, but in this case the two columns are TF1 and TF2. So the term frequency 1 and term frequency 2. And in the table, we see that, for example, the word loaf appeared 2 times in the TF1, but it didn't appear in the TF2. So TF1 represents the first sentence, and TF2 represents the second sentence. So with this, we calculated the TF. This is exactly the same as the count vectorizer, but keep in mind that some people have a different definition of the term frequency, but in most cases the term frequency is only considered as the number of times a word appears in a text. So exactly what the count vectorizer does. Okay, now that we have the term frequency, we're going to see how to find the IDF, so the inverse document frequency. So the IDF is calculated with the formula you see on screen. This might look intimidating, but when we implement this with Python, we don't have to make any calculation, but only use the sklearn library, and with that we can easily calculate all of this. By the way, sklearn assumes natural logarithm instead of the log that you see in this formula. So now let's calculate the IDF values for each word as sklearn will do it. So using the natural logarithm. Okay, in this table, I replace the values of the formula using the data that I had in the two sentences that I showed you before. And as you can see, the numerator in all the calculations is 3. So you see 3 in all of them. And this happens because here, the numerator is the total number of sentences plus 1. And the total number of sentences remains the same because we have the same number of sentences. So we have 2 sentences and 2 plus 1 is 3. And that's why we have 3 in all the numerators. However, the values in the denominator change. So we have here 2 and then 3 and then 2 and so on. And this happens because here the number of sentences containing a specific word in this list will change. So for example, we'll see that the word writing will appear more times than the word love. And that will change depending on each word and also on the sentence. Okay, now that I have all the values of the IDF, so here it's IDF1. I didn't write it correctly, but this is IDF1 and here is IDF2. So now that we have IDF1 and IDF2, we can calculate the TF-IDF1 and the TF-IDF2. So we only multiply the TF1 with the IDF1 and the TF2 with the IDF2, and here we have the values. And in this table, the higher the TF-IDF score, the more unique the term. So for example, here we have the highest score for love in TF-IDF1 and also Python. So these two words are more unique to this first sentence. While in the second sentence, the words hate and the words Java are more unique to this second sentence because they have the highest score. So we can say that if the TF-IDF score is high, that term will be more unique or more valuable. In contrast, if the score is low, that means that that word is not unique. So probably that word belongs to more sentences or more documents. For example, here the words writing and code appear in both sentences, and this is why we got a low TF-IDF score. Okay, now let's see how to implement this TF-IDF in Python. So let's go back to Jupyter Notebook. And now I'm going to copy this code that helped me create the account vectorizer. So this text variable. And now here I paste this code. And now I'm going to import a library, which is the TF-IDF vectorizer. So I write from sklearn.feature underscore extraction dot text import and then TF-IDF vectorizer. So this one. So now I'm gonna create an instance of this TF-IDF. So I write TF-IDF equal to, and now I copy and paste this TF-IDF vectorizer. Then I open parentheses and here I add this stop words parameter. So I get rid of stop words in English. So now it's here. And now I'm going to create a data frame so I can show you this table with these values that we calculated manually before, but now we're going to do it with sklearn. So here I write df and I'm going to create the same data frame. So here I just copy this because it's going to be the same. So now I paste it here. Now let's feed and transform this TF-IDF. So I write TF-IDF dot feed and underscore transform. So this one, and now I open parentheses and now I introduce the text data that we want. So df then square brackets and inside text. So now I'm going to run this to see the result. So now I run and again we got this sparse matrix, and now I'm going to name this result. So I'm going to name it TF-IDF underscore matrix. So here underscore matrix, and now we run this and we created this new variable. So with this I'm going to create a new data frame so I can show the TF-IDF score in this new data frame. By the way, here the feed underscore transform works the same way that in this count vectorizer. So the feed finds the best parameters, and then the transform the data that we have using these optimal parameters. So now let's create the data frame. So now I write pd.dataframe, then I open parentheses and write the name of this tf-idf underscore matrix. Then we transform this to an array with parentheses. Now the index gonna be, actually it's gonna be the same here. So I'm just gonna copy it. So I save some time. So I copy this and now I paste it right here. So this is the same index and the same columns because we're using the same text variable here. It's the same. We're just changing the approach. In this case, we're using the tf-idf vectorizer and not the count vectorizer. But here we have to make a slightly change. So instead of CV, here we write tf-idf. And now this is ready. So now I can show you this one. And now I run this. And by the way, the tf-idf vectorizer, so this one uses L2 normalization. So this is why we got these numbers. And to get the same result I got here in these slides, using the formulas I showed you before, we have to add a parameter to this tf-idf vectorizer. So this parameter is norm, and we have to set it equal to none. So by default, we use the L2 normalization, but with the norm equal to none, we'll be using the same formulas I showed you before. And we're gonna get the same result we got in the slides. So let's try this out. First, I run this, and now I run this one. And as you can see, we have now the same numbers that we got in the slides. For example, review 1 love is 2.8, and here review 1 tf-idf1 love is 2.8. So it's the same result. So with this, we successfully built our tf-idf vectorizer. And in the next video, we're going to see how to implement this in our project. All right, now it's time to put into practice the concepts we learned in the previous videos to turn data into numerical vectors. So in the previous videos, we balance our data. So we have imbalanced data, and then we use the random undersampler to balance this data. Actually, we saw two ways to balance the data. So first, we use the sample method, and then we use the random undersample. But for the analysis that we're gonna make in this and in the following videos, we're using the data we got with the random undersampler. So in case you only use the first method, the sample method, there is nothing wrong. The result is gonna be almost the same, but I'm gonna choose this one, and the output will slightly change, but it won't affect so much the result. So in case you want to have the same output that in these videos, you should use the random undersampler too. So I'm gonna run this, and after this we split the data into train and test. So here I run this again, and now we're gonna use this train underscore x, and we're gonna turn text data into numerical vectors using the tf-idf that we learned in the previous video. So I'm choosing the tf-idf because I want to identify unique and representative words for positive and negative reviews. And the tf-idf gives higher score to unique words within sentences. Okay, now to do this, let's first import tf-idf vectorizer as we did in the previous video. So we write from, then sklearn, then dot feature underscore instruction. So this one import, but before I have to add here that text. So now I can write tf-idf vectorizer. So tf-idf vectorizer. So now it's ready. So we press Ctrl Enter and we imported this tf-idf vectorizer. Now let's initiate an instance of this tf-idf vectorizer. So I write this, then parentheses, I add the stop word parameter. So stop underscore words equal to English. Then I'm gonna set this equal to tf-idf. And now let's feed this tf-idf with the data that is in the train underscore x. So we created before this train underscore x, and this variable has the reviews that we're going to feed into the tf idf. So now we write tf idf, and now I write the feed underscore transform method. So feed underscore transform, and then I copy and paste the train underscore x. So with this, we're gonna feed and transform this train underscore x. Now I'm gonna assign a name to this, and I'm gonna name it train underscore x underscore vector. Now I run this, and with this we have this train underscore x underscore vector. So now I'm gonna print it here, and this is a sparse matrix. And a sparse matrix is a type of matrix in which most of the elements are 0. So if I use the toArray method, we can transform this to an array. So here I run, and as you can see, most of the values are 0. So if you see here in the output that we got here, you see that this is a matrix of 1,340 rows and 20,625 columns. If you multiply these values, you're gonna get a lot of elements in this matrix. However, only 118,000 are non-zero values. So the percentage of non-zero values is little, and we can see that this sparse matrix has a lot of elements that are equal to 0. And here we can also create a data frame from this train underscore x underscore vector, but it's not necessary. But it can help you visualize how this matrix or this vector looks. I'm gonna create a data frame as I did in this example, but in this case, we're gonna have a lot of columns and also a lot of rows. And here I pasted the code that helps me create this data frame, and it's similar to the code we wrote before in this example, but in this case I'm not transforming this matrix to array, but I'm using the sparse attribute that this data frame has, and also the from underscore sp matrix method. And with this, I don't need to transform the train underscore x underscore vector into an array as I did in the previous example. So I run this, and now you can see the data frame, and as you can see, it has a lot of zeros, and in the columns we have the vocabulary used in the reviews. So all the words that were mentioned in the reviews in this train underscore x that I'm going to show you right now, so in case you forgot about it here, all the vocabulary used in these reviews are here in the columns. So every word that has more than 2 letters are taken into account in the columns, and these indexes represent the number of the review. Okay, now before we finish the video, we're gonna also feed and transform the test underscore x, because the test underscore x will help us evaluate the model that we're going to build. So now I'm gonna add here a cell, and now I'm gonna copy this one and paste it here. So now, instead of using the feed underscore transform on the train underscore x, I'm going to use it on the test underscore x. And actually, we don't need to use the feed underscore transform method, because we already got the best parameters when we feed and transform the train underscore x. And those parameters are here in the tf idf. So here I can only use the transform method. This one is also a method. Actually, there is a feed method and there is a transform method, and also a feed underscore transform that does both. But in this case, we only need the transform method because the tf idf already knows what are the optimal parameters. So with this, we transform the test underscore x, and we name this test underscore x underscore vector. So here test underscore x, and now I run this. And with this, we're gonna get a sparse matrix again. So let me show you, and this is the result. All right, in the following videos, we're gonna use the train underscore x underscore vector to build the model. And we're gonna use the test underscore x underscore vector to evaluate the model. In this video, we're gonna see the machine learning algorithms that we can use in our project. But first, let's see the difference between supervised and unsupervised learning. Machine learning algorithms are divided between supervised and unsupervised learning. In supervised learning, models are trained using labeled data, while in the unsupervised learning, patterns are inferred from the unlabeled input data. In our project, the input and the output are clearly identified. So the input is the movies reviews and the output is the sentiment, so either positive or negative. So we can say that we have labeled input and output data. Therefore, we're dealing with supervised learning. Two common types of supervised learning algorithms are regression and classification. Regression are used to predict continuous values, such as the price, the salary, and the age. Then, classification is used to predict categories, such as male, female, spam, not spam, or positive and negative. So in this case, it can be more than two categories. So it can be two positive, positive, negative, and two negative. So it doesn't need to be only two categories. So now let's make a recap and now let's see the types of algorithms we should use in our project. So first, we're dealing with supervised learning because we have labeled input and output data. Then we have to use classification because we want to predict the category of our review. So we want to know if the review is either positive or negative. So this is why we choose classification. And some of the popular algorithms used in classification are SVM, decision tree, naive Bayes, and logistic regression. And we're going to see the concept behind each of those algorithms and also how to implement them in Python. And we're going to see that in the next video. In this video, we're going to see the support vector machine algorithm. The support vector machine algorithm, also known as SVM, is a supervised learning algorithm that is mostly used in classification problems. We only need to feed the SVM model with labeled training data in order to categorize new text. This algorithm is a good option for text classification problems because it has a high speed and good performance with a limited number of samples. And we usually work with a dataset that has a few thousand of tagged samples in text classification. To understand much better how SVM works, let's see an example. So in this graph, we have two tags, green and yellow. Also, we have two features, X and Y. In a dataset, a feature is simply a column that represents a measurable piece of data that can be used for analysis. And in this example, we want to build a classifier that finds whether our text data is either green or yellow. So we plot each observation, also known as data point, in an n-dimensional space, where n is the number of features used. In our example, we only have two features, X and Y, so the observations are plotted in a two-dimensional space. The SVM takes the data points and makes a hyperplane that best separates the classes. Since the observations are plotted in two-dimensional space, the hyperplane is simply a line. So you can see this line now, and this red line represents the hyperplane that is plotted in a two-dimensional space. This red line is also known as the decision boundary. The decision boundary determines whether a data point belongs to one class or to another class. In our example, if the data point falls on the left side, it will be classified as green. And if it falls on the right side, it will be classified as yellow. And now you might be wondering, what's the best hyperplane? Well, it's the one that maximizes the margins from both classes. So you can draw many hyperplanes, but the one that is the best is the one that maximizes the margin from both classes. So in this case, the red line is the one that maximizes the margins from both classes. So now let's see how to implement the SVM algorithm in Python. And in Python, we can use the sklearn library to import the SVM algorithm. So we only have to write from sklearn then .svm, and then we import svc. So this svc belongs to the svm algorithm. So now let's create an instance of the svc that I should have written in uppercase. So now it's in uppercase. And now I initiate an instance by writing svc, then parentheses, and now we add the kernel parameter and set it equal to linear. So now we set this equal to svc, and then we fit this model. So we write svc, then fit, and inside parentheses we have to write the input and the output. So in this case, train underscore x underscore vector, and the output is train underscore y. So this train underscore x underscore vector is the vector we got here when we turn our text data into numerical vectors using the TF-IDF vectorizer. Here we got the train underscore x underscore vector that we're using right now. And later, we're going to use the test underscore x underscore vector to evaluate the models we're going to build. So now let's go back. And here I'm going to fit this model by running the cell. So I run, and now I wait, and now it's done. So here I use a linear kernel, but you can change the type of kernel if you want. And now we can use this svc to predict sentiment. So we only write svc dot predict, open parentheses, and inside we use the TF-IDF we created before. So this is going to transform the text that I'm about to write. So let's write a text that says a good movie. So this is my movie review, and I write a good movie. So with the TF-IDF that I initiated before here in the previous video, with this TF-IDF, I'm transforming this text into vectors. And then with the CSVC, I'm predicting the sentiment based on these vectors. So now I run this, and now let's see the result. But first, I'm gonna write these square brackets. So this is a list. And now I run, and we got that the sentiment is positive. So probably the SVC detected this good as a positive adjective, and this is why it output this positive sentiment. So now let's try with two more sentences. Okay, I just came out with two more movie reviews, and this one says an excellent movie, and the last one is I didn't like the movie at all. I gave this movie away. So let's see what the SVC will predict. So now let's run this, and we got that the first is positive. So a good movie, that's a positive review. So it was correct. The second is positive too. So an excellent movie. So it's a positive review. So it's correct. And the last one is I didn't like the movie and more text. And in this one, it predicted that is negative. So here it successfully predicted these three reviews. But with more complex sentences, maybe it can predict wrong. So we have to build the other algorithms and compare with each other, which is the best. And that's it for this video. In this video, we learned the concepts behind the SVM algorithm and how to implement it in Python. Alright, in this video, we're gonna see how the decision tree algorithm works. The decision tree algorithm is a supervised learning algorithm that can be used for solving both regression and classification problems. We use a decision tree to build a model that can predict the class or value of the target variable by learning decision tree rules inferred from the training data. To predict a class label for a record, we start from the root of the tree. So the root of the tree is this first node that you see here. Each node in the decision tree will evaluate the record following a specific rule. Then we follow the branch that corresponds to the result of the comparison, and then we jump to the next node. Let's understand much better how the decision tree works with an example. In this example, we decide whether a customer will churn or not based on some rules. Churning is defined as customers who leave a company. And in this case, we're going to see whether a customer churns or not based on the monthly charges. So here in my root, I have monthly charges less than 40? And this is kind of a question, because if the answer is yes, then we'll follow this branch on the right. And if the answer is no, we'll follow the branch on the left. So let's say the monthly charges is 30, and now we evaluate this node. So let's imagine this is a telco company. If a customer has been more than 3 years with the company, we say that the tenure is more than 3 years. So if that's the case, if the customer has been like 4 years with the company, then we follow the branch on the right. So we set churn equal to no. So if this is an old customer, probably this customer won't leave the company. But if the tenure is less than 3 years, so the customer has been with the company only 2 years or 1 year or only a few months, this customer probably will leave the company. So if the answer of this question is no, then we follow this branch, and then churn is equal to yes. Because if the customer has a few months or a few years with the company, most likely this customer will leave the company if the monthly charges has been less than $40. So with this, we finished the analysis on the right branch. And now let's say that the monthly charges are greater than 40. So let's say that this customer charge $100 per month. So we'll follow the branch on the left, and then we'll ask a new question. And this question is, customer has more than one product? And if the answer is yes, then churn is equal to no. So if the customer has many dependencies, most likely this customer won't churn, because usually companies give promotions and some benefits to customers who have more than one product. However, if the answer of this question is no, then we'll start asking more and more questions. And this is basically how a decision tree works. So now let's see how to implement the decision tree in Python. So let's go back to Jupyter Notebook, and we're going to use here again the sklearn library. So first we write from sklearn.tree, and we import decision tree classifier. So this one. Then we create an instance. So we initiate an instance from this decision tree classifier, open parentheses, and I'm not gonna add any parameter. I'm gonna leave it with the default values, and I'm gonna assign a name to this decision tree classifier, and it's gonna be DEC_tree. So now I copy and paste, and now I fit this model. So I write .fit, then parentheses, and use again the x and y variables. So now train_x_vector, and then train_y. So now I press Ctrl Enter to fit this model, and we successfully built this model. And that's it for this video. In this video, we learned the core concept behind the decision tree algorithm and also how to implement it in Python. Alright, in this video, we're gonna see how the naive Bayes algorithm works. Naive Bayes is a supervised learning algorithm that uses conditional probability to predict a class. It assumes that every feature is independent of each other, which is not always the case. So we should always analyze our data before choosing the algorithm. The naive Bayes algorithm is based on the Bayes theorem. And the Bayes theorem is the one you see now on the screen. So the first element, this one, represents the probability of event A given event B has already occurred. Then this one represents the probability of event A. This one represents the probability of event B given event A has already occurred. And finally, this one in the denominator represents the probability of event B. The assumption that features are independent of each other makes this algorithm fast compared to more complex algorithms. However, this assumption also makes the naive Bayes algorithm less accurate. So now let's see an example of this naive Bayes algorithm. In this example, we have this data that shows how many times players played a match under certain weather conditions. So we have to find whether players will play if weather is sunny. So this is our task. And here we have the formula. We replace the formula, but now with our task. So we have to find whether players will play if weather is sunny, and this is represented here. So we want to know the probability of event yes given event sunny has already occurred. And this is the formula. So now let's calculate each element to replace it and finally calculate this probability that we want. So now let's calculate the probability in each row and column. But first we have to calculate the total sum in each row and column. So here we have the total sum of each row and column and also the sum of the total values. So this sum of total values is 9. And based on this data, we can calculate the probability of each row and column. So here we have the probability of each row and column. And as you can see, the denominator is always 9 because that's the total number of values. So now let's see the probability of yes and the probability of sunny given yes and the probability of sunny. So the first one, the probability of yes, is this first column. So the probability of yes is 4 divided by 9. So 4 represents the number of times it's yes and 9 the total values. So we got 0.44 for this first probability. And now let's calculate the second one. In the second one, we have to calculate the probability of sunny given yes has already occurred. And in this case, we have to divide 3, which is the number of times players played in a sunny day. And we have to divide this by 4 because this is the number of times that player played in general. So 3 divided by 4 is 0.75. And finally, we have to calculate the probability of sunny. And this is this row. So sunny, 5 divided by the total values. So 5 divided by 9. And in this case is 0.55. So now we replace these values in this formula and then we calculate the final probability, which is 0.6. So now let's see how to implement this in Python. So we're going to use sklearn again and we write from sklearn dot naive underscore base, and then here I forgot to write the end. So now naive underscore base, and now import Gaussian and B. So this one. So now we initiate an instance of this Gaussian and B. I open parentheses and I'm going to name this one GNB. That stands for Gaussian and B. So now I'm going to fit this model. So I write that fit parentheses and inside train underscore X underscore vector and also the train underscore Y. And here there is a little detail you have to know. Unlike the previous algorithms we've seen, here we have to include that train underscore X underscore vector as an array. So we have to use that toArray method. So with this, we transform this train underscore X underscore vector to an array. And if you don't do that, it's gonna throw you an error. So now let's run this. And with this, we fit this model. And that's it. In this video, we learned the concepts behind the naive Bayes algorithm and also how to implement it in Python. Okay, in this video, we're going to see how the logistic regression algorithm works. Logistic regression is a supervised learning algorithm that is commonly used for binary classification problems. We can use logistic regression to predict whether a customer will churn or not, a mail is a spam or not, a sentiment is positive or negative, and more. The logistic regression is based on the logistic function, also known as the sigmoid function, which takes in a value and assigns a probability between 0 and 1. Then we get this S-shaped graph of logistic regression that you see on the screen. To understand much better how logistic regression works, consider a scenario where we need to classify whether an email is a spam or not. In the graph, if this z goes to infinity, our target value, so y, will become 1. So the email is spam. And if z goes to negative infinity, y will become 0, which means that the email is not spam. As I mentioned before, the output value is a probability. So if we obtain a value of 0.7, this means that there is a 70% chance that an email will be spam. Okay, now let's see how to implement this algorithm in Python. So we go back to Jupyter Notebook, and here I'm going to use sklearn one more time, and I write from sklearn that linear_model import logistic regression. So I write logistic regression, and now I initiate an instance of this logistic regression. I open parentheses, and now I assign this to log_rec. So this is the variable I'm creating, and now I'm going to feed this with the train x vector and with the train y. So I write feed, then train_x_vector, and then train y. So now with this, I'm going to feed this model, and now I just feed it. And that's it for this video. In the next video, we're going to compare the 4 models we built in this project. Alright, in this and in the following videos, we'll see traditional metrics that are used to evaluate models. And the first metrics we're going to see is the confusion matrix. A confusion matrix is a table that allows us to visualize the performance of an algorithm. This table typically has 2 rows and 2 columns that report the number of false positive, false negatives, true positive, and true negative. Okay, to understand what these 4 values mean, let's see the following example. Suppose that we have a computer program that recognizes dogs in a photograph, and we give it the task to recognize the 5 photos you see now on the screen. So here we have 3 photos of dogs and 2 photos of cats. So our computer program should recognize which photos belong to dogs. So this computer program recognizes that these 3 photos are photos of dogs. However, we see that 2 photos are photos of dogs, but one of them is not a dog, is a cat. So the 2 photos of dogs are the true positive because we wanted to obtain dogs and we obtain dogs. But the photo of the cat that was incorrectly recognized by this computer program is called a false positive because according to this program, the photo is a photo of a dog, but we know that this is the photo of a cat. So this is a false positive because it was selected by the program, but we know it's false because it's not a dog, but a cat. Then the values that were not selected by our program are either true negative or false negative. In this case, the cat that was not selected is a true negative because we asked to recognize the photos of dogs, and this is actually not a photo of a dog, but is the photo of a cat. So this is a true negative. In contrast, the photo on the right is the photo of a dog, but our program didn't select this photo for some reason, and this photo should have been selected, and this is known as a false negative. Okay, now that we know the concept of the values in this confusion matrix, let's see the convention for access. So the confusion matrix that I showed you before and that is now on the screen is the traditional confusion matrix that you will see in books. So usually confusion matrix follow this convention for access. So the true positive is in position number 1, false positive is in position number 2, false negative is in position number 3, and true negative in position number 4. However, sklearn doesn't follow this same convention. So sklearn has a different convention for access, and we should keep that in mind. So now let's see how the confusion matrix looks by default in sklearn. So by default, here we have the true negative in the first position, then false positive here, and false negative here, and true positive here. So this is the default order that sklearn follows, and as you can see, it's a bit different from the traditional confusion matrix. However, we can customize the position of this confusion matrix a little bit by using the labels parameter. So now we're seeing the sklearn, but with the labels parameter that I'm going to show you later when we go to Jupyter Notebook. But if we set the labels parameter to the values positive, negative, or also to the values 1, 0, we're going to get this order. And this one is slightly similar to the traditional confusion matrix. And we're going to use this confusion matrix in this project. Okay, now let's see how to implement the confusion matrix in Python. So we go back to Jupyter Notebook, and now we're going to calculate the confusion matrix of only the SVC. So this one that we created before. So as you might remember, the SVC was the first model we built, and this one came from the support vector machines, which is this one. So we're going to create the confusion matrix of this SVC, and then you can create the confusion matrix of either the decision tree, the naive Bayes, or the logistic regression. So it's going to be the same. So now to do this, we're going to import confusion matrix, and we write from sklearn.matrix import confusion underscore matrix. So now we use this confusion matrix and we open parentheses, and the first argument we're going to introduce is the test underscore y. So we write test underscore y, and this is also known as the true labels. So now the second argument is going to be the prediction. So we have to predict using this SVC model. So we write svc.predict, and then we introduce the test underscore x underscore vector. So we write test underscore x underscore vector, and now with this we predict the values that correspond to this test underscore x underscore vector. And here we're going to get the prediction of our SVC model. So we have the true labels, and these are the predicted labels. So remember that order when you build your confusion matrix. So now let's add the third parameter, which is the labels parameter. And with this, we're going to customize the access of the confusion matrix. So now I'm going to set it equal to positive, negative. So you can also write 1, 0, and with this, we're going to get the confusion matrix in this order that we've seen before. So now I'm going to run this, and here we got an array. So we got 4 numbers, and this one is the true positive, this one is the true negative, this one is the false positive, and then false negative. So 60 false positive and 45 false negative. And that's it. In the next video, we're going to use these 4 values to evaluate the models we built. In this video, we're going to see the first metric to evaluate our models, and this one is the mean accuracy. The model accuracy is defined as the number of classifications a model correctly predicts, divided by the total number of predictions made. That is, the true positive plus the true negatives divided by the total number of predictions made. So in the previous video, we calculated the 4 values using the confusion matrix, and now let's see this confusion matrix. So these are the 4 values, and we calculated using sklearn. And by the way, this is the confusion matrix of only the SVC model. So there are confusion matrix of other models too, but here, just to simplify things, I'm just calculating the confusion matrix of the SVC model. So now let's see the accuracy of the SVC model. So now we replace the values in the formula, and with this we can calculate the accuracy of the SVC model. So this one is 0.84. And now let's see how to implement this accuracy in Python. So in Python, we have to use the score method. So we only have to write the name of the model, in this case the SVC, then use the score method, and then inside parentheses we write the input and the output. So now let's go to Jupyter Notebook to see how to do it. So here in Jupyter Notebook, I'm going to start by calculating the accuracy of the SVC. So first I write SVC, then dot score, then open parentheses, and here we use the test underscore x underscore vector and also the test underscore y. So in this case, we use the test and not the train because the test dataset provides an unbiased evaluation of a final model fit on the training dataset. So we cannot use the training dataset again, but we should use the test dataset now to evaluate the model. So here I'm gonna copy this test underscore x underscore vector and test underscore y, and now I paste it here. And actually I can calculate the accuracy of all the models. I only have to write the names. So here I can write DEC underscore tree, which was the name of the decision tree model. And now the GNB, which stands for Gaussian NB. And then the log underscore reg, that stands for logistic regression. So now to show all the values, I'm going to print the 4 of them, and then we'll compare which one has a better accuracy. So now I print this, and here I got an error because I forgot to transform this test underscore x underscore vector to an array. So here we have to use the toArray method, and this is only required for the Gaussian NB as we've seen before. So now we run and we got the accuracy of the 4 models. And we see that the model with highest accuracy is the SVC model with 0.84. And this is the same value we obtain by calculating this manually. That said, this is not the only way to assess the performance of a model. So in the next video, we're going to see a different metric to evaluate the performance of a model. Okay, in this video, we're going to see another metric that will help us evaluate our models. And in this case, we're going to see the F1 score. So the F1 score is the weighted average of precision and recall. Accuracy is usually used when the true positives and the true negatives are more important, while the F1 score is usually used when the false negatives and false positives are crucial. Also, F1 takes into account how the data is distributed, so it's useful when you have data with imbalanced classes. The F1 score is calculated with this formula. So we have to multiply precision and recall and then sum precision and recall. Then we divide these two values and multiply it by 2. So now you might be wondering what's precision and what's recall. So to explain you the meaning of these two values, let's see this graph. And in this graph, we see the elements of the confusion matrix. So true positive, false positive, true negatives, and false negatives. So let's say again that we have a computer program, and let's say that our computer program selected this circle area with green and pink sides. So this circle is the selected elements, and this left rectangle is the relevant element. So these relevant elements represented by this left rectangle cover all the elements that we're interested in. This is why the selected elements that are relevant are called true positives, and the relevant elements that were not selected are called false negatives. Okay, with that in mind, to get the precision, we should ask ourselves the following question. How many selected items are relevant? So we see that the selected elements are in this circle, and those that are relevant are in this green area. So the result of the precision will be the true positive divided by the true positive plus the false positive. That is the green area divided by the whole circle. So if we replace the values we got in the confusion matrix, we'll get 290 divided by 350. So this will be 0.828, and this is the precision of the SVC model. Now to calculate the recall, we have to ask ourselves another question. In this case, the question is how many relevant items are selected. So the items that were selected and are relevant are inside this green area that you see now. and all the relevant elements are inside this left rectangle. So this recall will be the true positive divided by the true positive plus the false negatives. And if we use the values we calculated for the confusion matrix of the SVC model, we'll get 290 divided by 335, which is 0.865. So now if we replace the precision and recall and this formula, we're gonna get the value of 0.845. And that's how you calculate the F1 score. So now let's implement this F1 score in Python. So we don't have to make all these operations manually, but now with sklearn. So we go back to Jupyter Notebook, and here I'm gonna import F1 score, and I write from sklearn.metrics, and then we write import F1 underscore score. So now we use this F1 underscore score, we open parentheses, and again we use the test dataset. So we write test underscore y, then the prediction, which is SVC, because we're gonna get the F1 score of the SV model. So SVC.predict, then parentheses, and we use the test underscore x underscore vectors. So here I write this, and here we have the true labels and the predicted labels. So now we add the labels. So labels equal to, and then positive and comma negative. So with this we can calculate this F1 score. But here I'm gonna add another parameter, which is the average, and I'm gonna set it equal to none. Okay, now I press Ctrl Enter to calculate this F1 score, and we see that this first value is similar to the one we obtained manually here. And that's it. In this video, we learned the concepts behind the F1 score and how to implement it in Python. Okay, now let's see how to create a classification report. A classification report shows the main classification metrics we've seen so far. For example, the precision, the recall, and the F1 score. And now let's see how to create a classification report in Python. So we go back to Jupyter Notebook, and here we create a classification report. So we use sklearn, and we write from sklearn.metrics import, and here we import classification underscore report. So this one, and now we use this classification report, and now we open parentheses, write the test underscore y, then we predict the values using the SVC model. So we write svc.predict, then we predict based on the test underscore x underscore vectors. So I write this one, and now I add the labels. So the labels are going to be positive and negative. So I write positive and then negative. So as we can see, the arguments are in the same order that we've seen in the metrics before. So now I press Ctrl Enter to run this, and now we get this classification report, but it's not properly printed. So I'm gonna use the print function. So I write print, now I open parentheses, and now I run this, and we get this classification report properly printed. And here we got the metrics we calculated so far. So the precision, recall, and the F1 score. If you want, you can compare these values with those we calculated before, and they should be the same. And that's it. In this video, we'll learn how to create the classification report in Python. Okay, now it's time to see how to maximize our model's performance. Based on the metrics we've seen so far, we got that the SVC model performs better than the other models, but we can still maximize our model's performance. And we can use the grid search CV to make an exhaustive search on specified parameters in order to obtain the optimum values of hyperparameters. And to do this, we have to import grid search CV from sklearn. And after this, we have to set some parameters to find which is the optimum parameter. So here I write parameters equal to, and here I open a dictionary, and the key is going to be C. And here I write a list of values. So first 1, then 4, then 8, then 16, then 32, and then I write the kernel key. So I write kernel, and then I open a list and write two types. So linear and also the RBF. Then we initiate an instance of the SVC algorithm. So we write SVC with parentheses, and then here equal to SVC. Then we have to use the grid search CV. So I write it here. And in the first argument, we write SVC. Then as second argument, we write the parameters. And now I'm gonna add another parameter, which is CV, and I'm gonna set it equal to 5. Now I'm gonna name this SVC underscore grid because this one comes from the grid search CV. And now I'm gonna use this variable and I'm gonna fit this with the train underscore x underscore vector and also with the train underscore y. So now I write that fit, and here I write the train underscore x and then the train underscore y. So as you can see, this code is similar to the code we wrote to fit the SV model before, but now we specify some parameters to obtain the optimum model. So now let's fit the model. I press Ctrl Enter, and now this might take some time. So now I'm gonna cut the video and come back when it finishes. So now the execution is finished, and before I show you how to get the best parameters, here you can add more parameters to this grid search CV by pressing Shift Tab. So here there is a list of more advanced parameters. So for example, you can set the number of jobs and customize this even more with these parameters. So now let's see how to get the optimal parameters of this SVC model. So here I copy SVC underscore grid, and then we have to write the following attribute. So that best underscore params underscore, and we run this. And here we got the optimal parameters of this SVC model. We can also get the best estimators of this model by using the best underscore estimator attribute. So now I copy and paste this, and instead of params, I'm gonna write estimator. So with this, we get the best estimator of the SVC model. So now I run, and here we see the best estimator. And that's it. In this video, we learn how to find the optimal parameters of a model using the grid search CV.